गुड मॉर्निंग सर जी।
Good morning, Varun. Good morning, ma'am and sir. Suraj sir नहीं है क्या?
गुड मॉर्निंग।
Good morning, good morning.
बाल तो बड़ा झकास रंगवाए हो गुरु।
अरे हमारे सर जी हैं ये।
हम तो जैसे हैं वैसे ही हैं, कुछ बदला नहीं है।
हाँ, कलर खाली बाल का चेंज हो गया, ये नहीं था
हाँ
पहले।
हाँ, वो तो एज के साथ अपने आप चेंज हो रहा है। मैंने इसके लिए कोई कोशिश नहीं की है।
सही है, तो आप चालू करें।
हाँ, आप देख लीजिए, आपके पार्टिसिपेंट सारे ज्वाइन कर चुके हैं, नहीं कर चुके हैं। आप
हाँ,
एक
अभी
बार
आएंगे, टोटल 27 हैं,
ठीक है,
25 आ गए।
ठीक है।
तो ये ना मिक्स कैटेगरी है, जिसमें पीएचडी स्कॉलर्स हैं, असिस्टेंट प्रोफेसर हैं,
हम्म,
रिसर्च साइंटिस्ट हैं, एनजीओ वाले हैं, और कुछ
हम्म।
मेरे स्टूडेंट्स हैं अभी जो आ जाएंगे। तो अभी चालू करते हैं, मीनवाइल दे विल ज्वाइन। So
ठीक है।
I'll ask Priyanka to start the official proceedings, please.
Yes, sir. A very warm good morning to our eminent guest speaker, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, uh, Dr. Suraj Kumar Singh, faculty members, students, and all dear participants. I welcome you all on behalf of Suresh Gyan Vihar University on 21-day winter school in Geospatial Science and Technology. We are very delighted and eagerly looking forward to have you all involved in the quest of embracing knowledge. Now, with this, I would like to take a brief moment to introduce our guest speaker, Mr. Ritesh Kumar. He is Assistant Scientist Forestry at Harsek, Hisar. He has completed his BSc Zoology from Vinoba Bhave University, Hazirabad, MSc in Forestry from Forestry Research Institute, Dehradun, MTech Remote Sensing from BIT Mishra. He also qualified GATE in Ecology and Evolution in the year 2014, and he has many research publications on the go. So, with this thought, I would invite Mr. Ritesh Kumar to take forward today's program. Sir, you're most welcome, sir.
थैंक यू प्रियंका जी। सबसे पहले तो आई वुड लाइक टू थैंक द दिस ऑर्गेनाइजर ऑफ दिस इवेंट because they have given a thought to this such type of event to organize in such a situation where this it is very difficult to manage the, you can say, all the resources as well as the participants properly. uh, Still they are going ahead. Congratulations to them. So before I start, I would like to share my screen. Uh, so the topic assigned to me is screen sharing is not allowed. I think whether it is visible.
So, not yet, sir.
Yeah, I think you have to allow me to share my screen. There must be some restriction from there because here it has shown me that it is not. You are not allowed.
So, we'll just check. We'll
Yeah.
just check, sir. Just a minute.
Dr. Pranay, please check. Priyanka?
Sir, just we are just checking back, sir. The settings. So we have given permission. We'll again just check back whether it is
Yeah,
active or not. So
I will try to share it once again.
yes, sir.
Yeah, we can see it.
I think this time it is visible.
Yes, sir. Yes, sir. It is coming, sir.
Okay. So before I start, I would like to tell you that I am not a person of this Web GIS, but still, as per the request of the organizers, they have assigned me this duty that I should speak to the audience in relation to this introduction to Web GIS. And I will say that this is the requirement of this age right now. Although we have done lots of work in terms of creating layers and recreating n number of research, and on these research are giving some outputs, but how these outputs needs to be published somewhere, so that it is visible to most of the public, or many users can have access to such type of data sets. Although the government is also saying that you should share geospatial data so that this field can get you can say boost up, because somewhere I think it is confined to some users who has the knowledge of this GIS and remote sensing, but it should be made available to persons who are not aware even of this GIS. And you can say that Google is pioneering in this, but still a number of research organizations, and they are also doing some kind of GIS activities, and they have some spatial data set which is of quite good help in terms of planning, in terms of management of resources, but still they are lying idle in the either in the books or a thesis or somewhere in their hard disks. So it needs to be published, and I will say that very you can say curiously they have defined this introduction to Web GIS in this program. So let us have some glimpse of this. But before this, before I start talking about this introduction, this Web GIS, I would like to tell you something about this HARSAC where presently I am working. This is HARSAC. It is, you can say, Haryana Space Applications Center. It is a nodal agency of government of Haryana in the state of Haryana, working for the state. Any kind of activity, nodal agency means if any kind of activity is required by any user department or any government department, in terms of remote sensing and GIS, they have to approach to HARSAC. Either even they want to procure some data set, they have to approach HARSAC. If they want to have some drone kind of surveying, they have to approach HARSAC. So this organization was established in the year 1986, and it has become operational in the year 1989. So since its inception, you can say it has completed almost more than 200 projects. And those projects are quite you can say they are quite relating to the user departments, and the user departments are using those geospatial data sets which has been created under these projects. Right now we are having more than 30 projects which is ongoing, and hopefully these will be all successful one. Mapping, monitoring, manage, and all these resources, all these projects are relating to mapping of natural resources. They are sometimes related to monitoring and management of natural resources, environment and infrastructure in the state, as well as creation of sometimes of GIS database, maybe for the development planning or some other kind of planning, maybe some policy making also sometimes. We also aid other organizations in their research and development in the field of RS and GIS applications, maybe like horticulture department, maybe like agriculture department. If they approach us, and if they have some problem related to this remote sensing and GIS, we do help them. HARSAC also imparts training and education in the field of RS and GIS. To my audience, I would like to say that we are also imparting and delivering this MTech GIA, yani MTech Geoinformatics since 2009, and in collaboration with, you can say, Guru Jambheshwar University of Science and Technology, which is itself situated in Hisar. We have a MOU with them, and actually they are the awarding agency, but all the activities of teaching and this research as well as practicals, it is taken care by HRSEC itself. We also conduct ISRO-sponsored training programs in geoinformatics for different sections or different strata of the society, which as per their needs and demands. Like school students studying in class 10, 9, 11, 12, they are called to the HRSEC and they are trained, or even we go to field, or you can say we select 2 districts randomly from Haryana state every year, and we go there to make them aware in this technology. Now coming to this, the school teachers, actually they are also facing problem when they are coming up with this type of terminology, GIS. Right now, geography books, they are having these GIS chapters over there. So again, we train these school teachers, and we get these teachers from the SCRT, state, you can say, the Council for Education and Research Training is there. So they provide such teachers in either in geography, those who are involved in teaching geography over there. So even as right now I'm speaking in this 3 weeks training, we also run this 3 weeks training, which is ISRO sponsored for this teachers and you can say assistant professors or associate professors, those who are recruited newly by the government of Haryana in geography department or some other departments which needs some such type of training, either botany, zoology. They are also coming, but they are less in numbers, but most of them are from the geography department. We also give this you can say, we also cater to the needs of research scholars, PhD scholars or PG admitted students. So we also deliver 6 weeks summer training program, which is right now not being conducted because of this COVID situation. But we have, you can say this program is quite a successful one, because we get lots of applications for that program, and still we are getting query because we are not doing it. So that's why people are asking why we are not doing it. Just please start it. But because of the different norms of this government, we are not able to do it in physical mode. But still, after getting glimpse of this online mode of such type of trainings, as per your organization is doing, we will think on those things. So coming back to this was something related to my organization where I'm working right now. A lot more things are there, but still this is not the forum for speaking too much on that. But let us come back to this Web GIS. So this, as you are aware that this www, every time you are typing this www.google.com, इतना तो करते ही हैं सभी लोग. So this www means World Wide Web. This has transformed everything, and GIS is not an exception to this, because this has also transformed this GIS also. And thus this, you can say, the birth of Web GIS has come up. So what is a Web GIS? It is a computer software, or you can say hardware configuration. It is combination of computer software and hardware configuration which allows sharing of maps, this spatial data, geographic processing operations sometimes, and which can be given by your own network within your organization or even beyond that. Means आप अपने organization में कर सकते हो या फिर इसको बाहर भी दे सकते हो using common web communications protocols such as HTTP. Means there are some protocols also if you are doing some kind of activity on your own end, and if it is not under standard protocol, it cannot be communicated to any other organization or anywhere else. So we must follow this HTTPS, or you can say protocols, standard protocols. So most of the time, or you can say 100% times, Web GIS में resources are often sent from a centralized machine, which is called as server. Slowly and slowly we will try to build on this. अभी जितना बताया इसको यहाँ तक लॉक करेंगे. So थोड़ा सा एक टाइमलाइन के ऊपर भी ध्यान देंगे कि हाउ इट ऑल केम इनटू एग्जिस्टेंस, how Web GIS came into existence, timeline of some significant web mapping events that has taken place in the history. 1990, वहां पे आपका 1989 you can say World Wide Web, WWW. It was so simple when it was created. It was so simple. It was only able to tell or transfer some of the this you can say characters on the web. आज के डेट में you can see that it can handle maps. It can handle geospatial data set also. आप कुछ नहीं करते, you just install a browser and just you can have glimpse of maps.google.com. You can have maps over there. But ये इतना आसान नहीं था. It all has come up with era. Means 1990 में जो चीज थी वो आज के डेट में नहीं है, बिल्कुल अलग है. So initially in 1993 a map was published on web, and that was from Xerox PARC Map Viewer. Later on, 1994, Map Server was released, and in 1994, Atlas of Canada was released. So people started thinking of publishing maps or atlases on web. Then Tiger Web, it came in 1995, utilizing Map Server. Then MapQuest, Internet Mapping in 1996, and even in 1996, first generation internet-based GIS released by ESRI. ESRI को तो सभी जानते होंगे, Environmental System Research Institute, which was you can say defined and divided by University of California, I think, which is situated in Redland. So Autodesk was also parallelly playing over there in that era. Intergraph and MapInfo, they all came into existence in this 1996. And these are all big organizations, you can say, where you have job opportunities and your own, you can say, you can decide your domain where you want to expertise on, maybe Autodesk, maybe Intergraph, or maybe MapInfo, which is right now under this Bentley. Then in 2000, or you can say beyond 2000, GIO Server came into existence, means 2001. Afterwards, you can say an OpenStreet map, which is right now quite common. Anyone is using this OpenStreet map in their map publishing options. They get actually they publish the services also. Even if this is published from server, you can use it, or even you can consume their services in your own programs. So Google, or you can say NASA World Wind, it was released in 2004. Then Google launched Street View. आज के डेट में people enjoy this Street View. आप फॉरेन कंट्रीज के किसी लोकेशन पे चले जाइए, you will and you try to track those locations in this Google Maps or Google Earth. You will see Street View over there. You can move over there as virtually as you are there in this street. And it has come into existence since May 2005. Then June 2005, Google Earth and Map both released. ये कुछ टाइमलाइन है जिसको हमें से ध्यान रखना चाहिए. इससे हमें ये पता चलता है हाउ दिस थिंग्स हैज चेंज्ड. गूगल मैप्स फॉर मोबाइल, यस, आप आज के डेट में नेविगेशन विदाउट गूगल मैप्स यू आर नॉट डूइंग इट. 2008 it came into existence. Then GeoNote launched. Then Apple also released some mapping services in September 2012. Now 2012 again, ArcGIS online facilitation was also released. Means you can do some sort of activities, GIS related activities, maybe a special analysis on web itself, but by paying some money. Here it was a proprietary map provider for this Microsoft. It came into existence in July 2017, and still it is working over there. You can join such type of companies also. So this was the timeline relating to Web GIS mapping, how it came into existence and how it is changing the world. Now we will try to understand something related to how this Web GIS works actually. Before we go directly into this Web GIS, I will say that it is a kind of client server based technology where different computers are linked together with via internet or some you can say web applications, in which one is server and others are clients. इस चीज को अगर हम समझ लें यहाँ पे, तो आगे आने वाले स्लाइड्स में we will be able to understand more and more about the Web GIS. So client server is a computer technology model, you can say, that works as a separate client and servers. Yes, the server is a kind of computer also, which may have some applications or software to handle this server, because directly hardware is not going to be communicated by anyone. आप कभी भी अपने सिस्टम के साथ डायरेक्टली हार्डवेयर से कम्युनिकेट नहीं करते. इवन इफ यू हैव अ डेस्कटॉप, यू कम्युनिकेट इट विद द हार्डवेयर विद द हेल्प ऑफ सम सॉफ्टवेयर्स, मे बी ऑपरेटिंग सिस्टम. Similarly, the server is also having some software to make it enabled to be communicated by any client. So WebGIS uses web technology to communicate between some components, which is there a GIS server, which is identified by a URL. URL means www.maps.google.com. अब ये एक URL है, ये किसी का एड्रेस है, ये किसी एक सर्वर का एड्रेस है जो कि कहीं ना कहीं पड़ा हुआ है. एंड बाइंड इट, गूगल इज हैविंग एन नंबर ऑफ सर्वर्स. ऐसा नहीं है कि वो एक सर्वर है, हम क्लाइंट हैं, हम अपने सिस्टम से जब भी रिक्वेस्ट डालते हैं इस URL की, इट फेचेस अ मैप, एंड दैट मैप इज ऑलमोस्ट as per the IP tracking, the map is from your own location. वो उस एरिया का मैप खुलता है जो आप जहां पे रहते हो, जहां से आप लोकेटेड हो. So a client can be a browser, a desktop application, or a mobile application. Yes, client can be एक एप्लीकेशन हो सकता है जो कि आप इंस्टॉल करते हो, छोटा मोटा एप्लीकेशन. जैसे पहले हमारा ये भुवन इसरो ने लॉन्च किया था, तो इट वाज एप्लीकेशन. यस, गूगल अर्थ, इट इज स्टिल ए एप्लीकेशन. यू हैव टू इंस्टॉल एन एप्लीकेशन. Again, when this application is installed on your system is behaving like a client, and this application is bringing information from the server end as per your request. So, and this communication is done via a hypertext transfer protocol, HTTP और HTTPS. ये दोनों क्या चीजें हैं ये भी समझेंगे. And the format of the response can be an HTML, maybe binary image, XML, extensible markup language, or GML, geography markup language, और JSON, JavaScript, object notation. ये कुछ response आपके सामने हो सकता है just to visualize your map. कैरेक्टरिस्टिक्स ऑफ सब क्लाइंट सर्वर सिस्टम्स अगर समझने की कोशिश करेंगे तो ये भी हमें पता होना चाहिए. बिकॉज आई एम फीलिंग दैट इफ आई एम डिलीवरिंग दिस लेक्चर, आफ्टर दिस लेक्चर देयर मस्ट बी सम पीपल्स इन दिस, दे विल try to take this as an option in their career, because this is one of the best option right now to make a career in it. So I am also trying to say you something related to how these client server systems behave, or what is the characteristic of this. Is both the client and the server may reside on the same system. Yes, इसको थोड़ा सा समझने की कोशिश करेंगे. एक ही सिस्टम है, उसी पे सर्वर है, उसी पे क्लाइंट है, ये हो सकता है. But logically, hardware will be divided over there. Means each will have its own hardware. देखने में physically it will be same, but logically there is division over there. Means the same system can work as a client and the server itself. Clients are not designed to share their resources. Yes, हम अपनी resources publish नहीं कर सकते. client है तो आपके मोबाइल से कोई ऐसी चीज publish नहीं होती है. हाँ, लेकिन आपके मोबाइल पे नेविगेशन के लिए गूगल अर्थ या गूगल नेविगेशन का मैप खुलता है. इट इज कमिंग फ्रॉम द सर्वर एंड. हाउएवर इट कैन रिक्वेस्ट, यस, clients are there to they can request content from the servers. Yes, if you are in Delhi, you can request Delhi. If you are in Panchkula, you can request Panchkula. Yes. Just by tracking your location, it goes to that location, and zoom to that. The map is zoomed to that location only. A server can serve multiple clients at a time. Yes, you are not only one when you are dealing with a map on the web. N number of people are dealing with this map at a time. The number of client requests is limited for a server. Yes, but ये ऐसा नहीं है कि ये unlimited number of people can enter into this server. To handle such large of population, the servers are, you can say, it is having multiple copies over there. Again, and located at, physically located at different locations in the world. अगर आप मैप कुछ करते हैं गूगल का एग्जांपल मैं बार बार लूंगा क्योंकि मेरे को आसान होगा समझाने में, क्योंकि many people they are using this Google Earth or Google Maps. So उसको बेहतर समझने के लिए I will try to always make an example of that. So आप इस बात को समझिए कि when you are getting information about some restrictions or some hindrances on your pathway, it is coming from Google Maps. It is actually it is done on the basis of crowdsourcing. Whenever your this mobile is stuck, means someone who is going. Those who are stuck in the traffic, their mobiles, it is actually saying something to informing the server that there is a log jam over there or the traffic jam is there. So you are getting beforehand that information that there is a traffic jam over there. There is no sensor over there in the field. But on the basis of crowdsourcing, again, a kind of decision support system is given to you that you make a decision that another pathway is there. And even Google is will try to suggest you another path which is faster or which is although having less widened road, but still it is faster than the recent situation. So the communication protocol for the server and the client is the same, facilitating easy communications. अब मैं ये कहता हूं कि मैं आपसे मिला और मैं हाथ जोड़ करके आप हाथ जोड़ रहे हैं और मैं आपको पैर छू रहा हूं, तो अगेन द कम्युनिकेशन प्रोटोकॉल, एक प्रोटोकॉल जो होता है उसके अंदर सेम थिंग शुड बी देयर, मींस हैंड शेकिंग शुड बी देयर. इफ आई एम सेइंग समथिंग, इट शुड बी अंडरस्टूड बाय द सर्वर एंड. इफ क्लाइंट इज सेइंग समथिंग, it should be understood by the server end, and if server is supplying something to the client, it should be understood by the client also. So there should be some standard protocol for communication, facilitating easy communication, and these protocols are available in the application layer. If you are using some application, it is there in there. If you are using Google Earth, this software, this application is having that layer. Before we proceed, we must know some of the terminologies like AJAX, asynchronous JavaScript and XML. This is a technique that allows a web page to fetch information. बहुत आसानी से और आराम से समझेंगे. A technique that allows a web page to fetch information from the server without doing a complete refresh. Generally used in web maps for a smooth navigation. अब आपको बहुत आसानी से मैं समझाना चाहूंगा कि when you are trying to zoom in, it is a kind of command and request which is given by your client computer to the server. But if such type of applications are not playing behind, you will get a jerky look. Means something will happen and again the whole page will get refreshed. Means there will be a kind of कहते हैं ना shut down होना फिर खुलना, इस तरह का कुछ सिचुएशन बनेगा. बट ऐसा कुछ नहीं होता है. आप सिर्फ जूम करते हैं और बहुत स्मूथली यू विल गेट ऑल द इंफॉर्मेशन बिकॉज ऑफ दिस टाइप ऑफ जावास्क्रिप्ट ओवर देयर. API, application programming interface. It is an organized set of programming components that can be used to develop apps. अगर कोई ऐप डेवलप करना चाहते हैं आप, तो आपको अलग अलग तरह का API मिलता है, maybe in a particular language like Python, maybe you can say JavaScript or Java. वहां पे भी आपको API मिलेगा, and this makes your work easy because you have to just call the methods. Methods are there. आप मेथड का नाम है, उस मेथड को कॉल करना है, उस मेथड को इस्तेमाल करना है. अगर आप उस मेथड को लिखने चले जाएंगे तो it will become quite difficult for you to program a new thing, because again you have to write all the things for just that method. आप कहते हैं, सिंपल एक चीज बताऊंगा, just copy and pasting of some objects or some features which is there on in a layer, and you try to copy this to some another layer. So if you are trying to do this, a number of lines will be written to copy and paste, but still a simple step is there that you are utilizing, that is based on this modules or the methods which is working behind the scene, that makes the things easy. Client, a computer or other device that requests information or processing from a server. Cloud, a network group of computers. Cloud, आज के डेट में cloud, कोई भी संस्था, they are having this cloud systems over there. They don't have this physically in their offices, but they purchase it from some service providers. And this cloud is a kind of, you can say, network group of computers that can be used to supplement one's own computational infrastructure. अगर आपके पास सिर्फ मानते हैं एक सर्वर, छोटा सा सर्वर लगा रखा है, लेकिन आपको और ज्यादा रिक्वायरमेंट है, then you try to go to the cloud, because maintaining a server at your own end is itself a very clumsy process, because it requires 24-hour backup, because it requires a manpower which is going to cost you high. So access to cloud is often sold or rented. These are rented systems for installing or publishing your data set on the web. HTTPS, yes, this is hypertext transfer protocol, and S is S. आप जब भी आज के बाद आप जब भी वेब खोलेंगे या चेक करेंगे, then you will try to see आप whatever you are typing, www. something, maybe onlinesbi.com. Afterwards, this URL, this is the shortened URL actually, which is catering to some long URL which is encrypted. You will find that HTTPS is there. S always defines that this site is secured. Whatever information you are sharing on this site is transferred in encrypted mode, not as you are typing on the your client system. So if it is encrypted, and this encryption is also having some kind of layers, maybe 128-bit encryption, maybe 58-bit encryption is there. So n number of encryption level is there. So banks utilizes 128 this encryption level. So a mutually understood set of commands, you can say, and parameters often used by clients and servers to communicate over the internet. So I was just telling you that this is a mutually understood set of commands and parameters often used by clients and servers to communicate over the internet. So server is a powerful computer that offers specialized tasks. Why it is powerful? Because it has to work 24 hours into 7. This system once installed, it will not get switched off, which it sends. That's why this hardware which is installed over there, it has to be powerful and robust also. When it sends, because it is there always, आप 24 घंटे आप Google से question पूछ सकते हो. Then Google is not sleeping anytime. Although you go to sleep, but Google is not sleeping. आपको 12-1 बजे रात में या दिन में कभी भी कोई क्वेश्चन उठ जाए, आप उठ करके उसे पूछ लो, it will give you the response. So this type of server is there. SSL, this is secure socket layer, a web security strategy wherein communication is encrypted. Yes. And that's why this SSL, when this SSL is installed over there or used over there, then this HTTP becomes HTTPS protocol. Tiles अब स्पेशियल डेटा को अगर टाइल में ब्रेक ना करें तो इट इज वेरी डिफिकल्ट टू सेंड इट ऑन द वेब. So it is broken down into tiles or bundles or packets of geographic data, so which is usually a square in shape. Actually, at the client end, these square shaped tiles, they get integrated and your map is generated over there. Because it is coming in a standard protocol, that's why your client or this web browser or any application which is installed at your end is understanding the files over there, which is coming in packets. And even at different scales, which is so VGI, this is volunteered geographic information, means it is an open source geographic data offered by non-experts and collected through everyday activities. Everyone is having almost this Android phone with them. Even if you are not sharing any information, still Google is tracking you. Your map, your activity map can be seen in your this Gmail or Google login, where you have gone, how much time you have spent over there, all this you can get that map. These smartphones are actually making maps virtually, even without having any knowledge to the holder of this mobile phone or smartphone. Web service, yes. Now this is a kind of code that runs on the server and can perform a specialized task in response to a client request. Yes, अगर एक सर्विस हमने पब्लिश करनी है, this web service will have a kind of program or program which is there to perform a specialized task. Maybe हो सकता है किसी एक जगह का बेस मैप हमें लेकर के आकर के दिखा दे, and nothing else. Although the service will have a number of data sets which is beyond this base map, but still the service is only for making base map available to the client end. This will give you the base map. आप इसका एग्जांपल देख सकते हैं, ESRI ArcGIS, उसके अंदर आप बेस मैप खोल पाते हैं. That is a kind of service, web service given by some other servers. But still, when we try to just add that data in the table of content, it will get opened over there. And that base layer is coming from some other server, maybe maintained by some other one, maybe at cloud, or maybe ESRI or some other agencies. There is a complete silence from the audience side. I won't think whether they are getting my point or not. Hello? Hello?
Yes, sir, we are getting.
Okay.
Yes, sir, we are getting.
Okay. Thank you.
यस सर, आवाज आ रही है.
ये चीज समझ में आनी
Continue.
चाहिए, बस इतना ही है मेरा यहाँ पे पर्पस. So Web GIS आर्किटेक्चर के बारे में मैं कुछ बात करूंगा. Servers are usually configured with more computing power than clients, and they run a specialized operations in response to client requests. अब this Web GIS आर्किटेक्चर, इसकी आर्किटेक्चर में वेब सर्वर और डेटा सर्वर भी हो सकता है. Means they must often connect to other types of servers on the network to fully accomplish their tasks. Haryana is also having a GIS server beyond its own server, which is working for publishing normal kind of data set, maybe like application request, maybe like advertisement, maybe like informations related to Haryana. But we have another dedicated GIS server. Yes, this server, this is web server, has to communicate with GIS server when we are trying to when we try to publish some of the data set from this GIS servers, it has to go to this web server. Means it must be configured like that to see a screen and forward incoming request to the GIS server. So GIS server has the quality that it can perform cartography and as even allow you to some kind of special processing operations such as drawing maps and running geocomputational algorithms, etc. over there. You can see that external clients, maybe internal clients, maybe the people working in the organization itself, they can access this GIS server and work on that data set, or even that depends on the permission level that you have given, means the privileges that you have given to the client end. GIS Web Services, you can say it is a kind of piece of code that runs on the server and can perform some action in response to a client's request. So we will try to see in depth what is this GIS Web Services are. For example, a web service might receive some bounding coordinates and an image format from a client. Yes, so to draw a map image and then send the image back to the client. Itna hi hai. So maybe another type of web service, maybe this might be having may receive some vector feature coordinates also to calculate an intersection of those features and then send back to the client. So variety of commercial and open source softwares are available for setting up GIS servers. Examples include JIO Server, Map Server, ESRI ArcGIS Enterprise. These are actually software which is installed on some hardware. That hardware will behave like a server, but for this communication via this HTTPS, it is required. Means to make the system understand the communication, this layer is required, this application is required, either JIO Server, Map Server, or ESRI ArcGIS Enterprise. One by one, we will see what is the beauty and what is the facilitation or the facilities available in these servers, or you can say programs, software programs. So ArcGIS Enterprise, it is a kind of complete software system for all your geospatial needs to make maps, analyze geospatial data, and share these results to solve problems, another type of problems. You can make maps, you can visualize, analyze, and embed 2D and 3D data in the web maps. You can create apps. Yes, you can create apps without writing code with app templates. यहाँ पे आपके पास ऐप टेम्पलेट्स मौजूद है, आप डायरेक्टली अपनी डेटाबेस डिजाइन करके इसके साथ इंटीग्रेट कर दीजिए, आपका मोबाइल एप्लीकेशन तैयार है. आप हो सकता है कि एक दिन के अंदर, एक घंटे के अंदर, 2 घंटे के अंदर, इफ यू आर वेल versed with database, you can easily design a web mobile application within an hour. Just you have to define the database that you are going to create with the help of this mobile app and integrate it with the this app. Just build custom apps with built-in web app builder. Manage data means you can manage a geospatial data at the database level and create secure GIS content management system for your organization. Means if you are publishing it, it will be secured also, because once you are publishing, you need security certification for your publication. So it will create this security certification itself. Then only it will get published. If you are working in open source, you have to get a security certificate installed separately. Assess and report data quality. Input data from your existing cloud stores also. Means you can call these data sets in this program as well. You can share your layers, maps, and tools which you have created in your ArcGIS environment. Make your content accessible to members of your organizations and beyond that also. Set up trusted sharing between portals. If you want your data to be called in some other program, then you have to share it and you have to define a protocol which is trusted. Means ऐसा ना हो कि आपने डेटा शेयर किया और आपके डेटा को मैंने इस्तेमाल करने की कोशिश, पता चला हमारा डेटा चोरी हो गया. There should be some trust or kind of protocol that should prevent this type of event also. Share maps and layers between ArcGIS Enterprise and ArcGIS Online system. ArcGIS Online क्या है वो भी हम देखेंगे in the coming slides. Now coming back to this map server, ArcGIS Enterprise क्या है? It is a paid one. You have to pay lots of money to procure this software, ArcGIS Enterprise. Almost it cost around, I think, crores of rupees. Almost one license is of 60 lakh around, which has got all the capabilities to publish or to develop a application or to develop a mobile application, all this, or desktop application or dashboard over there, anything related to geospatial data handling, and make it be visible or visualizable by any or other organization also. आपके पास डेटा है, आपके पास पड़ा है, आप इसको विजुलाइज करा सकते हैं. आपने कोई काम किया है, मानते किसी ऑर्गेनाइजेशन के लिए, किसी अदर यूजर डिपार्टमेंट के लिए, उसको आप अपने सर्वर पे पब्लिश करके उसको एक राइट्स दे सकते हो कि आप यहाँ से देख सकते हो, इसको ये आप इस तरीके से इस्तेमाल कर सकते हो. Map server, it is a kind of, it is also a kind of server which is in open source, you can say, which is available for publishing spatial data and interactive mapping applications to the web. Originally, it was developed in the mid-1990s at the University of Minnesota, but this map server is released under, you can say that Minnesota kind of style licensing, free licensing is there, and it runs on almost all major platforms like Windows, Linux, Mac also. So this has got the capability to integrate inputs from, you can say, such of spatial data from different stores, and even consume services of, that is WMS, WFS, and tiles from different servers, and then again publish it in desired format. Maybe again WMS or WFS or WCS, which is called as web service, web feature service, or web, you can say, coverage service. And these all services are having capacity to handle different data sets, you can say. Map service will give you a map only. Feature service will allow you to share data sets like vector data sets, you can say. And coverage service is there to share this raster data set over there, over this in the format of SWF, SVG, PDF. SVG is a scalable vector graphics, or SWF is a kind of flash file supported by Adobe Flash Player. PDF is well known to all. Through HTML or simply images. Another application is also there, which is in open source domain, that is GIO Server, which is quite capable to handle spatial data and publish it on the web. It is designed for interoperability. It publishes data from any kind of major spatial data source using open standards. Open standards, again, open standard term is there. We will see what this open standards means and who is there behind these open standards. So GIO Service is quite capable of handling vector files in terms of shape file, database in which is there in PostGIS or Oracle or any other database handling system. Servers, which is itself giving WFS, ArcGIS, or even raster dataset, which is in different formats. So this GIO Server is again capable of publishing webs, this services in the form of web feature service, web map service, web coverage service, and keyhole markup language. This is a proprietary vector file format given by Google. So this open GIS standards or open standards, this is published by Open Geospatial Consortium, OGC. It is a worldwide community committed to improving access to geospatial or location information. So this organization actually represents over 500 business houses, government agencies, and many research organizations are also involved. Universities are also involved, which is working behind to define protocols for sharing one or the other kind of a spatial information and they are committed to make this locational information available in terms of fair, you can say, which is findable, which is accessible, interoperable, and reusable. So the community, this community actually, this Open Geospatial Consortium, OGC, it creates free, publicly available spatial standards, geospatial standards actually, which enables communication between open source as well as the proprietary softwares. OGC also, and you can say nowadays these proprietary softwares like ESRI products, they are also utilizing some of these OGC standards over there. So make so that their publications or their published data set is consumable by this OGC. This OGC also manages an agile and collaborative research and development process also. This runs on, you can say, donations basis. They also do some innovative programs and related to anticipations and solving real world geospatial challenges, which may be experienced in future or which is experienced by the members. You can also put your queries, your problems over there in this consortium, and you will get a solution. So OGC is a kind of client. No, you can say OGC is a kind of consortium which is defining protocols to communicate or interact successfully, to have to establish a successful kind of interaction between client and server. And both must understand the format of the protocol for issuing request and receiving the response. So this OGC has defined openness specifications for GIS Web Services, that is Web Map Service, Web Map Tile Service, or WMTS, Web Feature Service, Web Coverage Service, and Web Processing Service also. ESRI GIO Services specifications also outlines very similar types of services. Yes, they also define similar type of services for map delivery, vector feature transfer, geo processing, 3D scene viewing, and other GIS related operations. Now, this is all about how the server is working, how the server is going to handle the requests. What are the hardware and the softwares which is involved at the server end. Now the client end. So GIS client end applications are also there, which may be you can say which may constitute installed up desktop applications, maybe browser based applications, means directly it will be opened in this Mozilla or this you can say Chrome or Edge or Microsoft Internet Explorer. So, or you have to install a kind of application, maybe which may be mobile app, or in sometimes it is quite openable in native mobile apps also. Means you don't have to install any other application or any other source of application. So these are open source and proprietary applications programming interface, which is you can say create custom web and mobile applications which is consumed by GIS Web Services. Actually, these type of client applications include OpenLayers, Leaflet, and the ArcGIS APIs. The OpenLayers and the Leaflet, they are in open source, and the ArcGIS APIs, they are paid one. In order to provide an intuitive user experience, means you can say intuitive user experience, these client apps and APIs, they often hide the details of all the web service requests occurring in the background. आप केवल zoom in करते हो, but what is happening behind the scene is quite complex. Means n number of tiles are coming up, which is all maybe cached over there at the server end or at the client end, or which is you can say which is at different resolution. एक एक करके देखते हैं ओपन लेयर क्या है, लीफलेट क्या है, ArcGIS APIs कैसे काम करती है. Open layers, it is giving you chance to put a dynamic map in any web page. It can display map tiles, vector data, and some markers, which is loaded from any source, maybe many servers. These OpenLayers, they have got the capability, has been developed to further enhance the use of geographic information of any kind. It is completely free and it works in open source JavaScript. It is programmed in open source JavaScript. Similarly, Leaflet is there, which is quite capable of handling JavaScript, which is, you can say, developed in open source JavaScript, and it is quite mobile friendly because it is quite light. It consumes only 39 KB of a space of JavaScript and other mapping features, and it gives most of the mapping features which is needed by most of the developers. But this has got lots of plugins also. If you want some kind of enhancement, again, you want to do some kind of specific kind of activity by the mobile application, you have to use those plugins. So it is designed with simplicity and performance as well as usability by the developers. This ArcGIS APIs, they are bundles of, you can say, this is in the format of JavaScript, they are in the format of Python, they are also there in the format of REST. Means ArcGIS API for JavaScript is to build compelling web apps, which is there to unlock your data's potential with interactive user experiences. Means you can give capabilities for interaction over there utilizing this API. And a stunning 2D and 3D visualizations also. This ArcGIS for Python, API for Python is a Python library for performing GIS visualization and analysis, maybe a spatial data management and GIS system administration tasks that can run both in an interactive fashion as well as simply visualization purpose. ArcGIS REST API, this allows you to manage users, groups, and items within your ArcGIS online organization. You can also use ArcGIS REST API to access map feature and do some kind of analysis services on ArcGIS online system. So when there's many maps which is running in the client application, this may have origin in different servers. So they may be coming from multiple servers. Means base layer is coming from some maybe Google Maps, but vector layer, आप नेविगेशन के लिए अगर आपने अपने गूगल प्ले स्टोर पे कभी सर्च किया हो तो you will find that n number of applications are there for just navigation purpose. All of them, almost all of them, they are consuming base map of Google, and then they are having their own vector data which is get displayed during navigation. Means such type of base map as well as integration of base map as well as thematic map overlay, they are coming from different web services. So अब इसका फायदा क्या है? We can use this base map in n number of applications by overlaying different types of thematic layers. So this type of situation is called as mashup. Mashup एक word है जो कि it has come up from this music industry. They have done some kind of integration of confluence of 2 or 3 kinds of music, and then this mashup word is created over there. So this mashup is used to describe such type of situation where a map is created by utilizing 2 or more web services from different server end. So GIS client application means the server is quite capable of delivering vector data to client applications either as a standalone file or a streaming set of features. Means for this we need some file format which includes GeoJSON, ESRI GIO Services, JSON, and KML. This OGC has also defined a specification for vector features called GML. If you are using open source, you will go for this GML. Some client apps may allow the editing of vector features and transacted back and forth between a GIS database. Now, this editing arrow means arises like lots of questions. If n number of people are allowed to access this GIS database and they are doing some kind of editing, then this editing is there at client end. And if it is transacted back to the server end, then how the server is going to handle this edited data? Whether it is going to directly save it. Now there is a question that how to handle such situation, means how the server is going to handle this situation. So handler is this server is capable, or it is programmed like that. Either you keep the last edited version, means maybe Ritesh Kumar, maybe some other resource person is editing, but you keep the timestamp is coming over there with the edited data set. So the server will take into account while saving the last edited file, or at the client end we need to have this versioning kind of concept, means we have to define versioning of the same data sets. Different versions will be created. Again, the last version will be taken into account, that it is the final file which needs to be saved at the server end. So the server is made capable to handle such type of situation if you are allowing editing of vector data or any GIS database at the client end. So deploying mobile devices such as smartphones and tablets as clients of GIS servers, this is also quite you can say the kind of capability that these mobile devices, they are capable of handling situations where you don't have the internet access. Still, your GIS database is working properly because they give or facilitate some downloading of some of the files over there, which is there in your mobile itself, and on the basis of those, it is giving you the location information. So such type of mobile devices and smartphones or tablets, they are quite capable clients of GIS servers. They are able to, and if you are giving some facilities to these smartphones or GIS these tablets, means a person is going in the field and you are giving them this opportunity to edit some of the information over there on the tablet or smartphones. And if it is there, if it is not right now, it is the device is not having an internet access, the data set will be created over there, but still a synchronization facility is there. Once the internet facility will be available, the data set which is there edited in the edited format in the smartphone or the tablet will be supplied back to the server end, and it will be stored over there. Or if some updated information is there, again it will be stored over there at the internet access is available. But this device, mobile device or the client is having a capability to store all these changes or updates within it until internet accessibility is there. If you are publishing something on the web, this performance becomes an issue. आपको बहुत टाइम पे आपने देखा होगा कि आप कोई साइट एक्सेस करना चाहते हैं एंड यू आर नॉट गेटिंग एक्सेस टू दैट साइट. The chat is not coming from the server, whether either the internet of the server end is slow or internet of your client end is slow. Anything can happen, or there is some breakage kind of thing. So performance is again an issue if you are trying to publish something on the web. So users must keep in mind that must optimize all your these applications to give better or performance. So it is expected that a fast response will be there. अगर navigation के time पे your navigation application is not responding fast, then there will be a problem and confusion on the way, and you will be in trouble. And this handling this performance issue, it is a kind of challenging, because massive amount of data and processing is required. So administrator, means server administrator, they can improve the speed by reducing the number of transactions between clients and servers. Yes, you can limit. अब आपको पता है कि हमारे पास इतना ही रैम है और इतने ही हार्डवेयर लगे हुए हैं, तो इतने ही नंबर ऑफ लोगों को हम कैटर कर सकते हैं एट ए टाइम. तो यू कैन रेस्ट्रिक्ट दैट एट द सर्वर एंड एज वेल एज द अमाउंट ऑफ इन्फॉर्मेशन ईच ट्रांजैक्शन. यस, अगर किसी ने कोई रिक्वेस्ट डाला तो हो सकता है कि एक ट्रांजैक्शन हो सकता है कि बेस लेयर का हो, दूसरा ट्रांजैक्शन हो सकता है अदर लेयर का हो. इसको ट्रांजैक्शन को, इस रिक्वेस्ट को ब्रेक डाउन कर दीजिए सो दैट द इंफॉर्मेशन इज पास्ड smoothly on the web. So by minimizing the map layers or attribute data should be included in server requests and responses. Yes. अब आप कह रहे हैं कि हम मेरे को एरिया बता दो, किसी एक स्पेशल डेटा सेट का एरिया बता दो. अगर ये एरिया उसके एट्रीब्यूट में पड़ा हो तो इट्स वेरी इजी टू फॉर द सर्वर टू डिस्प्ले इट. बट आप कहेंगे एट द रन टाइम आप इसका एरिया बता दो, तो वो कैलकुलेट करेगा. वो कैलकुलेशन एक एल्गोरिदम चलेगी, वो कैलकुलेशन होने के बाद आपके सामने आएगा. इट विल टेक टाइम. So you can optimize such type of things by putting some of the things in the attribute data. Even you can enhance this performance by simplifying map symbols. Map symbols, if you have complex map symbols, again, when it is fetched from the server end and it is redrawn on the client end, it will take time. And its communication on the web is also complicated. Vector coordinate geometries. You must have seen. When you are trying to download data from USGS or any other server, they ask some coordinate files, vector files, bounding files. People try to give their own geometries of any area, maybe like district or state file. But this server will not accept that file. They ask you to simplify the number of coordinates or reduce the number of coordinates for the bounding box. Then only the server will be able to handle this vector data and respond to your request. Yes, you can reduce the file size by rounding the decimal numbers. Remember, as much this number of you can say number of precision information is increasing in decimal numbers, it is going to increase your file size, and this is quite difficult. It will become difficult for the server or the client end to handle this type of data sets. So you have to reduce the size of this also. So some of the activities which is required, and once you are doing such type of things, you will be able to handle such situations, because you will be aware of all these things. What sort of data sets and how to minimize this file size so that it can be transacted well by the client end, and request will be served by the server end. Sometimes use of tree indexing, multi-threading, and cluster computing is also there to speed up web map performance. We can integrate pre-drawn rasterized map files with a JavaScript, AJAX. Fetching techniques creates a map navigation experience so fast that it can appear seamless. This earlier also I have told you that this JavaScript, the AJAX, this makes this technique of creating a map navigation experience so fast that it appears seamless. Although it is not seamless, but it appears seamless over there, and it is quite utilized by this Google Maps. They have utilized it in 2000s, mid 2000s, you can say. Right now it is very common, but still it was pioneered by Google Maps. The tile motif, it is quite capable it is quite, you can right now capable, or by quite utilizable by the vector data packets also. Means you can divide your vector data into tiles, and again it is sent at the client end to be drawn over there, which allows actually more flexible restyling of cartography, which was earlier not possible with rasterized tiles. So if you are doing some rasterized, if you are sending your this vector data set in the format of rasterized tiles, so again your this cartographic limitations are there. So you can utilize vector data over there to be displayed at the client end and keep the styling of flexible restyling of cartography from this. Web GL, that is Web Graphics Library. This technology is often used for drawing vector files, tiles, or thematic features on the client side in a way that is faster than the traditional SVG, that is a scalable vector graphics approach. एक time था जब SVG was quite in use, but right now this Web Graphics Library is there. It is used for drawing vector files very smoothly at the client end. Now, performance is an issue. Security is also an issue. When you are trying to publish your data set, it may happen that it can be, once it is published on the web, anyone can fetch it. So to secure your data set and maintain the integrity, or either anyone can download it or fetch it, or anyone can manipulate it, so it becomes difficult. You must ensure that this type of data set, this special data set, is not revealed to a larger audience than intended. आप जितना लोगों को दिखाना चाहते हैं उतना ही को दिखाएं. आप इसको restrict कर सकते हैं by giving user ID and password. Security rules can be applied at various tiers and may restrict access to end user applications. GIS Web Service, map layers, geographic features और feature attributes. किन चीजों पे आप लगाना चाहते हैं? हो सकता है फीचर दिखाना चाहते हो, फीचर एट्रीब्यूट्स नहीं दिखाना चाहते हो, आप लगा सकते हैं. लेयर्स, डिफरेंट लेयर्स पे लगा सकते हो. कुछ लेयर्स आपको दिखाई देगा, कुछ लेयर्स नहीं दिखाई देगा. Although it is there on the server, but पब्लिक डोमेन में नहीं होगा. हो सकता है आपके डिपार्टमेंटल एक्सेस में लॉगिन पे सब कुछ दिखाई दे. हो सकता है बाहर वो चीज रेस्ट्रिक्टेड हो. When vector data is proprietary or copyrighted protected, it may be desirable to show only a rasterized image. अगर वेक्टर डेटा को आप नहीं दिखाना चाहते हैं तो सर्वर एंड पे वेक्टर डेटा रहेगा, लेकिन क्लाइंट एंड पे जब भी चीजें उठ करके जाएंगी ऑन द रिक्वेस्ट, इट विल इन द फॉर्मेट ऑफ रास्टर. मींस इट विल बी रास्टराइज्ड image of map data rather than the vector one. Means you will not get the vertex coordinates over there, but you will get a raster grid file over there. You can put limit on the scope of web service request. आप क्या request दे सकते हैं to wide web scraping, mass downloads, or enormous data processing jobs, which may overburden the server. अब इसमें एक वर्ड आ रहा है इंटेंशनली और अनइंटेंशनली. देयर आर पीपल दोज हु कैन प्ले विद द प्रोग्रामिंग, दे कैन राइट ए प्रोग्राम टू मेक ए कंटिन्यूअस रिक्वेस्ट टू योर सर्वर टू प्रोवाइड सम डेटा सेट्स, and in a way it will try to download all your data set while doing such type of things. And it may happen with the help of programming, writing a program. Hackers are there, they can do such type of things. Or programmer, I will say that hackers are having more knowledge than the programmers, because they are able to break down their security systems. Means they understand the technology very well. That's why they can get into this. So before you delve into this, you try to do some activities in terms of programming. Another thing that is there, that is GIS Web Services in the cloud. Yes, you may not be able to run your own server, so you can purchase the spaces and the cloud. So, and you can establish your web services over there, or publish your spatial data set from cloud itself. So cloud computing also enables the commoditization of GIS through a software as a service. SaaS model is there, software as a service model, wherein companies offer GIS web service in exchange for a usage fee. आपको एक fee देनी पड़ेगी. On the basis of that, you will be able to access this software as a service, and this includes ESRI ArcGIS Online, Carto, Mapbox. अब आपका जो fee based service है, this is offered on cloud. This might include data storage. आपका data storage की फैसिलिटी दे सकता है, ऑनलाइन मैप व्यूइंग का फैसिलिटी दे सकता है, जियो कोडिंग, रूटिंग एंड द यूज ऑफ स्पेशियल प्रोसेसिंग एल्गोरिथम्स का भी मौका दे सकता है. ESRI और GIS ऑनलाइन ये सारे मौके आपको देता है ऑन वेब पेज. कार्टो इज देयर एंड मैप बॉक्स इज ऑल्सो देयर. एक एक करके देखते हैं ये क्या है और कैसे आपको क्लाउड पे चीजों को रखने का मौका देती हैं, एंड हाउ दे आर एबल to provide you services from the cloud. This ESRI ArcGIS Online is built, you can say, it can build interactive web maps with ArcGIS Online, ESRI's web-based mapping software. You can also gain new perspectives and enhance details as you interact, because there will be data with you where you can zoom in and search on the map also. You can use smart data-driven mapping styles and intuitive analysis tools to gain location intelligence also over there. And this can be applied across your organization. And collaborative mapping can be done. Means you can divide your mapping activity in sections which can be integrated later on at the server end. You can see Carto is there in the field, and they are saying that a spatial analysis does not have to be rocket science. It has to be very easy. It has to be very common. So, to be understood by a common man. So, it's up to whether it is optimizing billboard sites, balancing sales territories, or designing supply chains. Understanding and analyzing spatial data is critical. किसी के लिए भी, आप अगर पिज्जा कहते हैं, अगर पिज्जा हट और डोमिनोज दे आर टेकिंग चैलेंज दैट आपको ऑर्डर करने के आधा घंटे के अंदर हम ये चीज दे सकते हैं, इट इज ऑल बेस्ड ऑन देयर दिस नेटवर्क एनालिसिस, व्हिच इज मींस दे आर गेटिंग मैप्स ओवर देयर, योर लोकेशन एंड द पिज्जा हट लोकेशन. So it will become one day critical to the future of your business. Even आप हीरो होंडा कंपनी, आप गाड़ी ऑर्डर करते हैं, आपकी गाड़ी कब पहुंचेगी यहाँ आप जहां से लेना चाहते हैं, वो उसको पता होता है, because they have this tracking system over there. Once the vehicle is being supplied from the production site to the delivery site, proper tracking is there when it will reach. तभी तो आपका वो धनतेरस का प्रोग्राम जो है फेल नहीं होता, वो उसको सप्लाई कर पाता है. Carto's location intelligence platform allows organizations to store, enrich, analyze, and visualize their data to make spatially aware decisions. Yes, आप कमिटमेंट दे रहे हो, बट यू आर नॉट अवेयर दैट कि वो कहाँ है, कहाँ पहुंच गया है, पहुंचेगा या नहीं पहुंचेगा. So your commitment or your decisions should be supported by spatial data set. Mapbox. it is a glimpse of this. One video is there, quite good one, that I have taken from mapbox.com, site of this precise location data and powerful developer tools they are giving to change the way we navigate the world. Yes, they are defining this applications for vehicles. Vehicular navigation जो आजकल आप देख रहे हो ना, navigation system vehicles में लगा हुआ आ रहा है, वो ये चीजें बना रहे हैं. This type of applications which will be able to show you locations fastly in your vehicle. Means you don't have to have another mobile application for that. So what are the advantages while keeping your services or GIS Web Services in the cloud? One benefit is that there is no need to acquire and administer on-site GIS servers. ना हमें हार्डवेयर खरीदना है, ना सॉफ्टवेयर खरीदना है. ठीक है, it is there, just we have to deploy our data set. Means, but still थोड़ी सी चीजें हमें देखनी पड़ती हैं, that is इंटरनेट कनेक्टिविटी, स्पीड एंड बैंडविड्थ. ये चीजें हमें ध्यान रखना पड़ता है कि जो सर्विस प्रोवाइडर है उसका इंटरनेट कनेक्टिविटी, स्पीड और बैंडविड्थ जो वो देने वाला है वो क्या देने वाला है मुझे एट द टाइम ऑफ, एज वेल एज द सिक्योरिटी ऑफ डेटा ट्रांसफर्स. मैंने किसी सर्वर पे अपना डेटा रख दिया क्लाउड पे और पता चला कि वो चोरी हो गया, तो हु विल बी रेस्पॉन्सिबल? द सर्विस प्रोवाइडर और द पर्सन हु इज promoting this in his organization. So there is a issue. Another advantage of GIS in the cloud is elasticity, means the ability to expand back end computing resources. आप बढ़ा लो जितना बढ़ाना चाहते हो. आपको अभी मेरे को रैम चाहिए, अभी ठीक है 80 GB चल रहा था, मेरे को नहीं 150 GB रैम चाहिए, तो 150 GB रैम भी वो देने को तैयार है, because they have that kind of capability, and this is quite flexible in case if you want to increase your scope of work. But we must know that अब ये फाइट हमारे ऑर्गेनाइजेशन में भी चल रही है कि हम अपने ऑर्गेनाइजेशन में अपना सर्वर मेंटेन करें. अपना सर्वर तो है ही, but whether we should go to the cloud or not. So there is a point to pay attention, that is economics behind the scene, to understand whether the fees associated with the cloud services are lower than the cost of deploying a server on site. अगर आप सर्वर रखेंगे अपना, you will have to have a manpower, at least 2 or 3 manpower, because it needs 24-hour attention, backup of maybe either genset, DG or battery backup, or you can say online UPS system. Everything needs to be installed over there. The server room itself needs to be cooled down very frequently, because transaction of data sets produces lots of it. Now how this Web GIS and the society, how they are taking into consideration all interacting, or the Web GIS or the society, how this society is interacting with the Web GIS. You can say makers of maps and GIS data often rely on the web as a simple way to deliver content to the public. Yes, आपके पास map है तो है. What is the utility if it is not delivered to the society? Whenever we put some stalls in some of the trade fairs or some other venues, we find that, or workshops, we find that people are interested in maps, and those maps are physical maps. They are even ready to pay for that. So if it is there on the web, you can just tell them that you can approach this site and you can say take or visualize this map information over there. This includes the sharing of downloadable vector. Yes, right now there is a policy change from the government of India side. They have made this national policy for data sharing, and even one dedicated organization is there, National Specific Data Infrastructure, and SDI. They are working behind the scene, and they have created a policy that any government department, if they are having data sets, spatial data sets, they have to put it on the web compulsorily. And you have to make some of the data sets downloadable also, so that this GIS field may get boosted up. Because of I think that many of the students or the researchers they get stuck over there because of lack of availability of data, and you have to make these data sites searchable also, where the web also augments the potential of public participation. Yes, this also augments the participation of publics. Yes, a number of people are going where you are not there. Actually, means you can just give a app or an application on your web or your mobile. When a person is trying to visit some national park, just to tell them to click on the web map to identify areas of high intrinsic value and places lacking maintenance. Just yes, we have given some road up this mobile application here in Haryana that was given by HARSAC itself. That mobile application was capable of just you have to click a photograph of the, if you find a pit hole or some of kind of breakage in the road on the highway or any road, just click a photograph with the help of this mobile application and upload it. All the things, it goes to the authorities and they have to take action on that with lat long, and such type of applications are there, which is quite helpful. And public participation can enhance the this system also of planning, management, everything. This is one of the, you can say, dashboard of properties and taxation, which is implemented in the district of Gurugram. And this has been developed by HARSAC itself. So every household is mapped over there, and the constructed area is defined by, or constructed storage is supplied by HARSAC itself. Then only this property tax bill is generated, which needs to be paid by the property holder. Recently, there was a request from the Haryana Education Board. They said that we always find it difficult to, you can say, define a school as a center. So we need some type of database which will have information related to number of teaching staffs, number of benches and desks, classroom size, as well as CCTV camera over there and where it is located. So we have tried to create such type of database, the dashboard of which is before you. This dashboard is an online dashboard. Anyone can see it, but no, anyone cannot see it because it is restricted. It has got login ID and password. So you can see this is the total number of our schools, and these are the locations of our schools which has already been mapped. And this mapping is not done by any of the staff of HARSAC. This has been done by the school teachers. We have just developed a mobile application and given it to the board office. They had supplied, and we have not given it to anyone actually. We have put the link of this mobile application on our server, our HARSAC's website, and people are using it. Another example, क्या मैं अपना स्क्रीन शेयर कर सकता हूँ? एक जीता जागता एग्जांपल दिखाना चाह रहा हूँ वेब जीआईएस का, जो कि HARSAC ने इंप्लीमेंट कर रखा है.
Yes, sir. Sure. Yes, sure, sir. You can share your screen.
Okay. ये आप देख रहे हैं, ये दिस इज यू कैन से डिजिटल रिकॉर्ड है ऑफ हरियाणा स्टेट लैंड रिकॉर्ड, यू कैन से. Here you are getting information related to Murabba and Khasra, as well as village information which has been digitized from Musavis or Sajra map given by the revenue department to her side. Here you can go and search by Khasra, select district, maybe Hisar, select Tehsil, maybe Hisar, select village. So village is selected, select Murabba, then Khasra. Now the beauty of this application is that this is also giving you information related to who is the owner of this plot right now. You can see Kamal Singh. कब किसके पास रहा ये information भी है, and this information is not integrated in the GIS server. This information of ownership is there in the NIC server. At the runtime, when I am requesting a particular Murabba and Khasra, this server is facing this information from NIC server. Although the special information is coming from GIS server. So this is a kind of mess up. This is an example, live example of application of Web GIS. So currently, the world is of Web GIS. Whatever you are doing, you must have some kind of approach to learn this technology. Other applications are also there, but still I have to share my screen from some other forest department. We have created lots of data set for forest department. Now they have published it on the web, but restriction is there, and the restriction is limited to usability by the forest department officials only. Means they have user ID and password, they can log in over there and they can enter into it. That data set is published. So other a number of related information or related applications can also be generated. Maps.google.com. Again, it is a kind of Web GIS. This gives information. You can say, right now it is giving me information that I am in Haryana Agriculture University. I have not zoomed in. Automatically it has opened like this. And it is saying that moderate traffic is there in this area. So you can see how beautifully this Web GIS is working, integrating information from the crowdsource as well as its own servers. So coming back to I think the time is over, but still I was having some case study with me. वो फिर कभी हम लोग करेंगे. I think back to the organizers. It's over from my side.
Thank you, sir. It was a very good presentation, sir. And we actually enjoyed it and learned quite a lot from this presentation. So I would request all the participants, if you have any queries, you are most welcome to ask. Any questions to sir? It seems it was very self-explanatory, the presentation that you have given, sir. Thank you so much.
Sir, I have a question. Varun sir, sir ji.
हाँ, बताइए sir.
Yeah, lot of data sets is available with HARSEC. So if a person wants to use the data for research purpose, so can you provide it, or we have to just pay for some that data?
Data said no. There is a kind of collaboration. If you are coming to HARSEC for the research purpose, you can utilize the data set in the HARSEC itself, and you can take away the maps
Okay, okay,
like ISRO.
okay. तो अभी आप लोग प्लानिंग कर रहे हो कि if you are planning for some server that can so you can
It is already there, Varunji. It is already there. We have procured this cloud server from RailTel,
okay,
which costs around 10 lakhs of rupees per annum.
okay, okay, okay.
So manpower is there. 4 to 5 manpower is there. They are working behind the scene. This all the CODB that we have seen right now, it is working from this RailTel server.
Okay, okay, okay. Means you are just developing such kind of server at HARSEC.
Yeah, we are trying to publish the things or the data set in the public domain so that the public will be able to, or the user departments will be able to maximize its utility. Because you can see that you can say an administrator is there. He has tried to create some database. He has got the data set in the form of DVD or CD. He has kept it in Almira and he has been transferred. Right now, the other person who is there, he is having no idea whether he has got such type of data set or not. He is again asking that such type of data set from the HARSEC. ये सिचुएशन है इस टाइम पे. दिस हैज हैपेंड विद एग्रीकल्चर डिपार्टमेंट. हमने उनको डेटा दे दिया, बना दिया, सब कुछ कर दिया. अब वो डेटा सेट जिस ब्यूरोक्रेट ने खरीदा वो चला गया, उसकी विजन चली गई. अब दूसरे जो आए हैं उनको मालूम ही नहीं है. So if it is published on the HARSEC website, so directly you can tell that you can go there and search. You can see.
Okay, okay, Sirji. Thank you very much. It was very informative and very enlightening lecture on the Web GIS. You have covered a lot of basics of Web GIS in a very well manner and very simplest way. So I think most of the students are now very aware with the topic that is Web GIS. So if anyone have any question, any other student, so you can ask. Any question from anyone?
Next,
Priyanka?
Yes, sir.
Hello.
Yeah.
Oh.
Yes. Ritesh ji, thank you very much for enlightened with your deep knowledge on Web GIS to our students as well as all the participants. Thank you very much.
Thank you, organizers.
And with this note, I would like to call upon Priyanka. Please call our next speaker and introduce him. Thank you,
ma'am. Thank you, sir. Thank you, ma'am. Now, with this, I would take a little moment to introduce our next speaker. Dr. Amit Kumar is an assistant professor and coordinator in the Department of Geoinformatics at Central University, Jharkhand. His research in the past 15 years has focused on man-environment interaction, disaster risk and resilience, and climate change implications primarily in urban milieus. He is engaged in various research and development projects, including LTEO, NISAR, GISAT, and AVIRIS and GS, and he has published over 75 research articles in various journals and book in international reputed, including PNAS. He is a member of various academic society, including IUCN, CEM, South Asia, NAGI, ISEB, ISG, ISRS, and GFBI USA, and many more. So to his hat, he has many feathers. And with this thought, I would like to invite Dr. Amit Kumar, Assistant Professor, to take forward today's program. Sir, you're most welcome.
Yeah, thank you, Priyanka. Thank you for such a nice introduction. And thank you, organizers, especially Dr. Suraj and Dr. Shruti Kanga. They are a very good friend of mine, and they are really doing amazing there. I can check their profiles regularly and found the amazing work. And thank you for giving me the opportunity to deliver a talk in this winter school related with the geoinformatics application. So I'm going to share my screen. Is my screen is visible?
Yes. Yes,
Yeah.
sir.
Yeah, thank you very much. So I think I can start now.
Yes, sir.
Yeah. Uh, uh, Today I am going to give a brief idea about some of the application related with the urban areas and some few case studies with concerned with the forest. So considering these two, I am going to uh, basically give you a glimpse about the various aspects of remote sensing application from optical to SAR, some and convergence with the GIS modeling techniques. So I will start with the perspective, which is of area like urban, which is in my terms, it is one of the gray area for the entire globe, which is approximately covering only 3% of the land mass, Earth land mass, but it is accommodating almost 56% of the global population. So this small segment of areas having large concentration of population, and definitely it leads to the significant changes, means influence on the local and the regional environment. As per the estimation, like it is going to be increased by 60% population in the cities, and the net growth of the cities during this period from 56 to 60%, the major part of the population will be residing in these large cities itself. That concerned to a lot to the urban areas. And during this changing climate condition, increasing intensity of extreme events in terms of flood or heat waves, or we can say cyclonic events, where all these things are very popular these days. Almost every month we are able to encounter some of these words, and which is very much evident. And in this concern, remote sensing has plays a very vital role. Not only it's monitoring the damage, its impact on the landmass or the region where it's going to, it has impact, but also in the forecasting. And definitely when we do go for forecasting, like these days for cyclone and other climatic meteorological activities, IMD is doing very well. They have doing it with a large set of data sets and very powerful servers, so that their estimations these days are very much realistic, and we can say very much precise as compared to previous decades. So these are the concern in the urban areas that we are facing. And here I am representing one of simple map, which is the rate with the population growth from the period 1985 to 2015. We can see this two color segments, that is an orange representing the year 1985, while the dark color, something brown, is the population in 2015. In this particular decadal variation, we can see how this population in different regions of India has increased. We can easily identify this segment of pocket is the Delhi and its neighboring areas, while it is the eastern India and dominated by, we can see the large circle is Kolkata. And in the south, we can see Chennai and the Kerala regions, so with a smaller increase in population. So we can see how the population distribution in these urban areas is very much uneven. We can see the segments, certain segments which I marked in the red color, are the major zones of the urbanized population, while the other regions, that is in the Himalayan segment, we can say, and the northeast India and the central parts also, and we can see this Rajasthan western regions are also very much deprived with the number of settlements, number of good number of cities also. So that is, we can say, this is definitely driven by the geographical and various socio-economical political concern, where definitely geography word is very much dominating. But this also highlights the uh, flow of the resources and the problems, if any, like in any concern, like this area, we can see this whole area, there are large number of cities are there, and this large segments in this coastal region, Indian coastal, it's in the Kerala region, it's also. So in case of any tsunami or such activity is happening, so these segments are very much affected. So what type of measures can be done, what type of planning can be done in the holistic manner at the pan India scale can be determined with some of these activities. So in the background, I have placed the physiographic zones in different color, and we can see the physiographic zones like the Himalayan regions has very less, and only the valley regions and some of the cities are in the regions, while other regions like in the Indo-Gangetic plain are very much rich in terms of the cities, and these cities are very much concentrated in the western as compared to the west eastern part and other regions. Uh, Let me know if my slides are not visible, because very often it's going
Yes, sir. Your
disconnected.
slide presentation has just moved,
Okay, just a minute.
stopped actually.
Is it okay now?
Yes, sir. Now it is visible.
Okay. So this is, in this slide, I am going to a glimpse about the growth of the urban population during this period and how these are linked with the other activities. So in this particular slide, I'm representing the various hazard events, that is primarily the flood, drought. We can see the legend here, flood in the, we can see we have a different concern, like we have a flood in the green color, less than two incidents, 2 to 5 in the orange color, and greater than 5 events in the red color. This is the information based on the EM data sets, and we have plotted the major case incidents of disasters at the pan India scale and linked with the cities. So we can see that major disasters like flood, drought, cyclone, earthquake, landslide, and tsunami, all these things are very much common in Indian scenarios, and cities in this area are affected by one and multiple hazards in the region. We can see these coastal cities are very much prone to and affected with the tsunami, because the data we have covered is from 1980 to 2010. In this period, a very much large tsunami was occurred, while the other regions this particular western coasts are not affected with tsunami. That is, we can say, because of geological activities going in the Indian oceans, that was a major reason. While we can see in this western regions and this particular southern regions with the red dots are very much uh, affected with the some type of drought scenarios, while the Indo-Gangetic plain are very much affected with the flood scenarios with the varied intensities. So that this particular assessment, when we have plotted we in the graphical form and in the map, we come to know that flood is one of the major significant disaster which is affecting a large and with the increasing intensities major cities, and it is very popular in the Indo-Gangetic plain, Northeast India, where the population is definitely low, and so that risk was less as compared to the other regions. And these years, in the last few years, and in the recent decade, we can see the regions which were not reported for the flood is having that concern. So that recent decade was not included in this one, even though that concern I have mapped in the different perspective. So in this, I'm showing one small case study, how this urban growth, which is very common these days in remote sensing perspective, and also in the literature is very common, how this urban growth is appearing and how the pattern is there of this urban growth in the Himalayan regions. So we have identified the 7 major Himalayan cities in the entire stretch from the eastern to central to western Himalayan region, including Nepal and Bhutan, also the capital cities we have considered. I mean, we have tried to see how the land use was changed over the years in this area and how the growth has taken place over the region. We found that it has 3 major cities, that is a Srinagar. It is the first one is Srinagar, this is Shimla, this is Dehradun, this is Kathmandu, Gangtok, this Itanagar, and Thimphu. So in this region, we have found that this three major cities are there in the Himalayan region, that is Srinagar, Dehradun, and Kathmandu, where the large implications, large urban growth was taken into account in Srinagar. We can see these three bars are there representing the urban growth scenario 1972. This is 1972. This is of urban area in 1991, and this is urban area of 2015. We can see how these cities has grown over the years in this 1972 to 1991 period, and the large growth was taken up in 2000 in the Srinagar during the period 1991 to 2015, while the second one is Kathmandu. And we, when we have related it with the landscape and development concern in that area, we found that Kathmandu region is almost saturated because of the hill around their entire region. So, and as Dehradun and Srinagar is concerned, there are various areas in their periphery which is either occupied by some of the other like segments, which is restricting its growth in that manner. And all these three cities, which is growing at large segment, as having the pattern which is we can attribute as a haphazard growth. So we have did this exercise, and we know that further we are doing for other studies with reference to their climate change and growth modeling, which is under process right now. And a few of the segment from this slide onward, I am going to focus on the city, which is Ranchi, and from last 15 years, I am working in this area. So this is one of the satellite image of the Ranchi city, and which is one of the not very large, but having the rapidly growing city in the last 22 decades and 20 years. So it is occupying only 175 kilometer of area as a municipal boundary. But over the years from last 1972 to 2010, it has grown a lot. The growth was from 19 square kilometer to 124 square kilometer over these years, and we can see the spatial development of build-up area in this region. And this is the corresponding image of 1975 by the Landsat. This is the corresponding image of 1991 by Landsat TM. This is Landsat TM plus, ETM plus, and the another was the same of 2010. So this multi-temporal satellite data is very much used to evaluate the growth of this region, which provides the how this, when we linked with the population increase, we found that there is a large leap in the build-up growth over the period, where there was the increase in population per year, increase in population was having decreasing trend. It means that population density was after this period was decreasing over the years. The build-up area which is taking place outside is actually having the low density type of development. Means persons are having a large plot per unit area over the periods. That is because of the changing scenario. Like in 2000, year 2000, this is the capital. This become the capital of the newly formed state Jharkhand from Bihar. So after that, changes in the recognition of the city itself as a capital from the ordinary city, it has the change in the administrative and political concern. This has influenced a lot. And this is the again the land consumption pattern over the year. We found that the land consumption pattern has been increased over the after the period of 2002-1, the consumption pattern was increased with the per person concerned. In this, I am going to show the same land use, whatever we have prepared, the land use pattern. This is our entire land use we have plotted with the satellite imagery, and the older one, when the satellite images was not there, we have used the Berkeley USGS topographical sheet of 1927 as a reference. And the changes we found that the increase in the build-up area is very large, and that similarly, we found that the green area as well as the agriculture area was reduced over a period. And in terms of the population influx, the increase in the area, it was very drastic, and we can see that it's linear and regular growth over the years. And we can found that the changes, like we found that 80 square kilometer has been net growth during the period 1975 to 2010, while the agriculture area was reduced by 60 square kilometers, water body by 2.8 square kilometers. Similarly, the vegetated areas were reduced by approximately 20 square kilometers. So this type of assessment can easily be drawn, and this is the land use transformation over the different periods. Yeah, this is very interesting. The same type of study we have performed for the other cities, neighboring cities of Ranchi. That is, this is for Ranchi. This is Jamshedpur urban agglomeration, and this is Dhanbad urban agglomeration. We found that a large segment of agriculture area in the vicinity of these cities were transformed to build up. It means the in this plateau region, the agriculture area is also limited, and that is also very much prone through transformation to the build-up areas when they are very near to this type of some cities. And we can found this conversion was very much high in the Rachi, like I said, 90%, whereas it is almost 66% in the Dhanbad, whereas it was least up to 15% in Jamshedpur. And the difference is like that. Definitely, Jamshedpur is city is planned and it has some few outgrowths in the northern and some other parts also. But definitely, because of this planning concern, the this transformation from agriculture to build up was very much less. This is one of the image. I have shown you the zoom area of two segments. That is one industrial. This is one commercial area of Ranchi city itself, and near to that we have one heavy engineering corporation. This is with the this building structure is there, and this is the nearby land use. And again, this is the one of the more government institution network. So what why I am showing you here, this is the output of one of the satellite data. This is worldview 2, and we have used basically to see, this is the FCC image. This is their PCA based image, and we have used NDVI. We have used, basically we have tried to extract some model for automatically extraction based on some indices in this region. So what we have used this PCA based buildup index and the NDVI to extract the buildup area as well as the green area in the urban region using the very high satellite images. That is worldview 2. It has a resolution in the multispectral mode is about 2 meters. While the panchromatic is approximately 0.5 meters. So we have used this data set for extracting this one, and we have performed tests it with the various other than available classification mechanisms, in which we have used the unsupervised one. We have find that this PCA based method and the NDVI based on the red edge has add-on precise classification method as compared to the older one methods. So this, we can see, this is the one of the hilly area, and this is one plant location of the city Durba, and it can very exactly identified in this classification method as compared to the this unsupervised classification. So high resolution data sets, when it is there, definitely it is very interesting to see small means a very minute feature, very precisely you can able to map also the buses and the cars moving along them. But it is very hard to work on it because it occupies large set of data sets, large space, as well as high computing system for that. And when you go with the data, like whatever you are interacting with the Google Earth image or Google Map, the backend data is also very large. So it is the performance of the Google servers that is providing you the data seamlessly, and you are able to make decisions. So when we are able to see the coarser data sets, definitely it is very like you are able to say large views, something like that. But when you zoom in and able to see the objects at a large scale, definitely it is very interesting, but data processing as well as other methods are very much complex. But here with the advent of various new algorithms, we are able to identify this thing very easily. So this information we have used basically to understand the build-up density as well as the vegetation density in the entire region of Ranchi city itself, and we found that the density we have classified into very high, moderate to low, and we found that the city in the core area and elongated part from the western side is having the high density, and another patch is near the HEC area, and other regions we can found that its intensity was under the sprawling, means it is a in the fragmentation manner it is developing. And while in terms of vegetation density, we found that it is a vice versa of the build-up density itself. Definitely, the areas having the moderate to high density of build-up areas having also the green cover that we found here, but the large segment of vegetation is found in the southern part, that is Dhruva and HEC area, as well as Kake and the northern area. And we can see based on this green and gray, that is the vegetation and build-up area combinations, we are able to understand what type of ecological concern is there, what types of urban dwellers are having the total environment in their periphery. So this type of assessment provide you if you are going for selecting any planning process, what type of method we can plan, what type of tree plantation activities required in certain areas, which area is very much proper or provide the better output. Means optimum resource allocation can be done using this type of maps. In this slide, we are relating the groundwater trend and fluctuation. We have observed basically a 4-year data sets from 2007 to 10. In this slide, I'm representing the basically groundwater level, depth to groundwater level, that is during the peak monsoon period, post monsoon period, non-monsoon period, and pre-monsoon period. We can see this particular during the pre-monsoon, the groundwater level is very critical and it is going beyond greater than 7.5 meter below ground level, and the fluctuation we have observed, it is very high during the peak monsoon. It means the trend of this particular groundwater fluctuation is becoming higher during the August, which is pre-month. This is basically peak monsoon period. So in this concern, we found that the changing pattern of the precipitation in this area has a large influence in the groundwater scenarios. And we have also tried this trend analysis and other things and try to relate which area is having the higher groundwater fluctuation as well as the change in depth. We found that the peripheral areas has having the problem, which is basically related with the different geological perspective, basically hard rock terrain in the periphery area, as well as some segments of the city regions, which is very largely covered with the buildup, that is impervious surface, are facing such problems. The same method, in the same line of the previous slide, this is based on the various factors like geological, geophological, then we have the drainage density and other land use concern we have integrated to understand the groundwater potential in the region. We found that the potential is very low in the area which is highly populated and having the high density of impervious area, that is we can found in the red dark brown color in the center part of the city, where other regions excluding the hard rock terrain we can found the density is the groundwater prospects are very much high. So again we are going to relate this groundwater fluctuation and groundwater level during the particular pre-monsoon period with the basically the contour density as well as the buildup class, and we found a very good correlation among them, and we are able to understand what type of this stress in the red colors are related with the areas. This like this Doranda area is having the almost a high vegetation, high build-up density, as having also the high groundwater fluctuations over the years. Likewise, it is related with the groundwater level over the years. This is a very old edge technique while using the satellite image In this, I'm using the World View 2 satellite image and relating it with the topographical concern. We found that this changes how this drainage over the years are eliminated or encroached by the build-up growth. We can see this black color line is representing the drainage as per the topographical map of 1972, which is just gone, and we can see large density of the build-up area taking place over the area. Not only this, we can see some remnants in terms of this red color smooth patches are there, which is actually in 1970s is and before that it was a small seasonal channel which is passing through from the middle of the city, and which was over the years were encroached by the build-up growth. And we can see this remnants becomes as a low-lying area, and which is having the moisture and becomes the source of water sink, and later on become the nala and something like that. Not only that, during the time of heavy rainfall, it leads to inundation in this area, and people used to cry that the inundation was increased. This was definitely a seasonal inundation is, and very short-term inundation is there. So that type of assessment is very popular, and remote sensing we are using it to understand scenarios. In this the other perspective I am exhibiting like the average ambient noise level in Ranchi from the period 2005 to 2010, and in this we can see the every year the average ambient noise level they are plotted. You can find these segments in the red color spots are those locations which were having the high ambient noise level. It is almost greater than 75 dB, and we can see over the years this particular ambient noise was increasing. We can see the segments were very much popular in the area in the central part and some of the southern and northern part, which you can say moderate, but later on it has increasing, and in 2009 itself a large area has been covered with the high, moderate to high and critical level of ambient noise level. This data we have collected based on the in situ observation, which is of this different traffic junctions over the years, and that is plotted in the GIS, and later we have used to interpolate the data and understand the situations, how this build up areas and within this heavy to critical zone of ambient noise levels is getting affected, and how healthy the systems are in these terms. So we have considered those many factors and also try to relate the urban green space that we have plotted previously with the noise level, and we found that the ambient noise level is in the purple color over the area, and the urban green and tree cover we found plotted. We found that where the tree cover density is very high, the ambient noise level is low. Even the traffic junctions are there, but because of the tree concern, the annotation was very much affected and it was reduced. So that in spatial term we are able to map. This is other parameters in terms of the basically the atmospheric pollutants, that is SPM, RSPM. It is a few point data sets in the area, so we are not able to exactly spatially overlay create this map. So we have analyzed the trend in terms of the temporal behavior, and we try to see how the ambient noise, ambient air pollution like SPM and RSPM are increased, and it has an episodic trend over the different seasons, and we try to relate with the vehicle increase over the area, and we found that the vehicle increase as it is related, it has influencing the SPM RSPM, but very much not related with the SO2 or NOx. And again, this is a land surface temperature using the Landsat series of data sets which has a thermal band inherent, and we are using the data set to understand the land surface temperature behavior. It is a map of somewhere 2000 year 2000 and 2014, and we have tried to see in the month of May basically the land surface temperature within the urban area. This is a core urban area, central part of the Ranchi city. The urban areas and the LST has increased drastically. And we can see the airport area, which is a runway. Runways are visible here, is also having the high LST over the area. over the years. And not only this, the zones under the, we can say, rock outcrops and hard rock terrains were there, exposed rocks are there, which is having the high LST. Almost 3 to 4 degrees centigrade has been increased over the years. It implies basically the changing pattern, like after 2008, there was a typical drought segment years, and the decrease in rainfall pattern with the erratic concern. Basically, the total average rainfall, total cumulative rainfall was not decreased, but basically there is a tendency of erraticness, means there is a high rainfall with a high intensity rainfall under the period of a week, where are other next consecutive few weeks where there is no rainfall, something like that. So we have tried to see the that pattern also, and from 1960 to 2010, we have tried to analyze the climatic variability, meteorological variability, using the temperature trends and the precipitation. We found that the number of rainy days were definitely very high over the particular years 1994 to 2000, and thereafter post 2000 period it has decreased, and thereby we can see a very small period in 2006 more or less. There was an increase in number of rainy days, and we have plotted the total rainfall days. We found that the number of rainy days has been decreasing, but the trend in overall concern, the number of daily rainfall days is almost very less changed. It means the intensity per day rainfall has increased. And based on the temperature and rainfall concern, basically we have tried to understand the scenario. It is based under the number of warm days and mean temperature over the years. We try to find that the trend changes, like decreasing in the total number of warm days as well as mean temperature is identified as a cool period in Ranchi, followed by the warm period from 1970 to almost 1985. Thereby, there is again a coolest period, you can see, from 1986 to 2001, and thereafter the hottest period from 2001 to 2010. So there is a decrease in the increase in the mean temperature very drastically, as well as the increasing number of warm days in the blue color. So when we evaluate these things, we found that the drasticness has in temperature and precipitation pattern both has increased in the city. This is based on the temporal observations. So why we are, once I have shown you the variety of the data sets from groundwater fluctuation and this ambient noise level, aerosol, that was I have not discussed, but it is a part of the study, the growth, buildup, density. We have taken all this account into one, and considering this all variables, we have included to understand the geo-environmental hazard in the urban area at the ward level. So whatever data we have collected, we have tried to segment it at the ward scale, and we have tried to see its influence, like it is a bad influence or a good influence, and classify that concern and try to map the hazard zones within the city itself. When we found that the zones, which is basically central part of the city, as well as the western part, and considering this all variables are very much under high hazard as compared to the peripheral areas. While the vulnerability is concerned, the ward level vulnerability is decided and prepared based on the demographic concern. So vulnerability is, as far as vulnerability is concerned, it is representing the population concentration in the ward. We can find one ward in the northeast area, and central wards are very much highly vulnerable because of the population. While combining these two, hazard multiplied by vulnerability, we found that the central as well as northeastern and some western wards are very much under high risk considering these geo-environmental variables. So whenever we can have to plan about the remedial measures, mitigation plan, or the new future growth, we can consult this type of understanding, maps, and the data sets in the spatial concern to planning and so. In this, I am just representing some of the other perspectives, like here the seismic activities Nepal, which is occurred in 2015, very much devastating event was there in the Gorkha basically Pokhara region. We have tried to see how this regions were having the seismic tendency over the last 100 years. And we found that there are this particular 2015 earthquake was not a single case. There was variety of zones which were receiving the earthquake or seismic intensity over the years, but the intensity are of different nature. Here, this is a year wise we have plotted, whereas we can see the same thing we have plotted in terms of the decadal distribution of earthquake based on the magnitude. We found that the red magnitudes are very high, which is recorded in the different past years, and these are the recent events which were observed during the 2015. And we try to use these data sets to understand what type of risk it may generate based on the population and the affected assets in and population density in combining with this one. And we are able to come up with the zones, which is central part of zone, which is having the high intensity of a moderate earthquake, as well as we can see is also the zone of very high affected population and assets, and also it has a moderate to very high population in the region. So that type means we can understand this region is definitely geologically very active, but on the other hand, is very good or suitable for the build-up development because of the limitations are very much geographical limitations are very much challenging for build-up growth in that area, Himalaya region, where there are very few segments or few zones are there which is good for the human settlement. But those areas again we can see in the Himalayan central Himalayan regions is very much active and a very history of the very high magnitude of earthquakes. In this, we try to drop down to the urban scale, and based on the SAR data, interferometric SAR assessment, we try to generate the fringes over the entire region. This is in central. We have generated. This is this basically the Kathmandu city area is there, and we have generated the fringes along that and try to relate it with the two mega 2015 earthquake events, that is in 25 April 2015 and another one is 12 May in 2015, and we try to see how much this is having the proximities with reference to the city itself. And later we have tried to analyze based on that we have tried to analyze the displacement in the entire city scale, and this is the build-up map and non-build-up scenarios. And combining these two, we have this is the ward map of ward-wise population density, population in persons basically. And we have combining all these two, basically the displacement and the build-up. We have tried to see the what type of displacements were faced or observed in the build-up and the non-build-up areas. And considering this fact, the total displacement in the region, we have generated the hazard, and based on the population we have generated the vulnerability, and combining these two we have generated the overall earthquake hazard risk for the Kathmandu city region at the world scale. And we found that even though the hazard is very much high in the southern and the western part of the city, the risk is also very much highlighted in the southern parts as well as central as well as northwestern parts. So we are able to understand how this high intensity earthquake has affected in the at urban scales. Definitely, the large part of the Himalayan regions were affected, but the regions which is non or inhabited, which is non-populated, is having no loss. Okay, it has hazard, it has no vulnerability, thus it has no risk. But where the population concentration is very high, and in the initial slide I shown you, the increasing population density in Kathmandu city is very much popular. This region is also very much significantly affected during 2015 earthquake. Now, apart from this, I'm coming to the forest, a few glimpses of the forest studies. Basically, I have just laid out two studies in this area. One is related with the basically GIS and SAR-based studies. If you have any questions so far for the urban concern, you may please ask.
It's okay. It's okay.
Okay, so I will go ahead. Okay. Okay, fine. So in this particularly, we have generated, we have done one case study in the Satpura Tiger Reserve, and this is the map of the black boundary of Satpura Tiger Reserve, and in the central India. And we try to, based on the detailed field study, we have worked on the tree density, the diversity, the basal cover concern, and the estimate the field-based biomass. So I would like to show you the first this slide, which is the basically a field layout. These all points, these are the field visit sites that we have performed during the last 3 years, and approximately we have covered uh, 181 field points over this area, and that leads to the preparation of this type of map. So these grids are related to the field sites, and we have taken 1 point approximately for the each grids wherever it's feasible in the forest, and to try to see the tree density and diversity over the region, and how this tree density and diversity is related with the above ground biomass. So based on the allometric equations, we have and the species DBH data sets, we have tried to extract the information about the above ground biomass and try to relate with the this basically elevation and other parameters. We found that wherever the diversity is very high, that area is having the high AGBs in the Satpura Tiger Reserve. So we later on we try to use these ALOS based ALOS 2 L based data sets, and also try to use the Sentinel 1 C based data sets to understand what type of backscatter data is coming over this region, and how this backscatter properties of different polarization, like LOS2 has a 4 polarization, HH, HV, BH, and HV. That the 2 are the cross polarization and 2 is the co-polarization bands. And again, Sentinel-1, which is freely available data set only is providing with the 2 bands, VH and VV. One is cross and one is co-polarization. So we try to see how this backscatter properties of the forest in the different segments, like high density, high diversity, high basal cover, low basal cover, those concerns are mapped using this backscatter properties. So when we have related this field-based biomass with the backscatter property, we found that the higher correlation were observed with the cross polarization, that is approximately zero point 0.8 with the VH, followed by HV, it is again 0.81. So this study and the previous reports also confirmed that the band of cross polarization, especially VH, is having the very high correlation in terms of because it can penetrate much deeper in the forest canopies as compared to the other bands and provide the better assessment for the forest area. Now, the same thing we have when we performed with the C-band data sets, that is Sentinel, we found this particular VH is also there, but the tendency was very much the correlation was not very good. That is only 0.2 R square value are getting. The concern is that the penetration level is very much subjected to the band selection also. Like C-band is can interact with the canopy initial few centimeters or few centimeters it can penetrate, while this L-band can penetrate to the branches, to the large part of the canopies also, and it can also interact with this stems also, and main stems also, based on the this concentration of the tree canopy itself. So as this is very much sensitive, this L-band can interact very well with the forest. It can provide you the better information, but whereas this C-band is interacting a few centimeters, it can provide you the less information as compared to L-band. That is the one output we have observed. The other part is that the trend of estimation is almost same. Like even though we can see wherever the L-band, this is a particular map, wherever the L-band is having showing the high AGB, same area is again represented as a high AGB in C-band also, and wherever the L-band is showing the less AGB, is same details were observed in the C-band, but the definitely trend is same, the values are different. And when we check with the field data sets, it is very much matching or related with the L-band data. And one more concern that is observed, that this there is a saturation in the backscatter value of when the AGB is too high. So it is not a AGB, this SARDETS, LBAN datasets also is not very much uh, uh, useful in the tropical forest area when you go in the rainforest like Amazon. And so that if the AGB is higher than 300 megagram per hectare, it is not possible to detect the particular detail. So that these days the fusion of optical and the SAR is very much popular. This is one of the same informations we have tried to depict it in terms of the field photograph. Thus, this is the Landsat OLI based image from where we have collected the data set in the field in the transept of 40 by 40 meters. And this is the field photograph corresponding to this satellite image. And this is the final output map. And we found that the dominant species in these areas are some specific, like GGPS is there, Tectona grandis is there, Melusia tomentosa is there, and Terminologies tomentosa. These are the prominent species in this region. While in the other parts, we have other species concerned, like dominant species and their associations are almost different. So it is the species dominance and their associations also have influence on the above ground mass estimation. Now, this is almost, I think, one of the very interesting perspective of the forest, where we have used this particular C-band data sets. Like L-band has a very good role in the forest vegetation because of its penetration and a quad pole concern. Definitely, it's very good. But the temporal availability is very much available with the C band, which is Sentinel 1A or 1B, which is very much available for the from 2000 to these periods, very almost after 15 days, more or less. So we have used this data, Sentinel C band data of 2017, 18, and 19 for these many days, almost 158 scenes we have used for 79 days to process it and try to plot this phenology. Now, phenology is the concern how the trees here has flushing, how the leaves are flushing in the tree, how it is getting matured, how it is getting falled, and once the tree is totally leafless, how it is coming up. So that reflectance value, that backscatter value, we have tried to evaluate over the period for a particular species. Tectona grandis, we have taken few samples in the field of the same nature, like it is a good cluster of Tectona grandis, and taken into account the backscatter value and try to see how this trend of phenology is from satellite image or this SAR image is related with the established phenogram of Tectona grandis as in the literature. We found that basically this is again the same trend of like leafless period and there to the leaf flushing period to that trend over the years 17, 18, and 19. We have plotted into the basically in this particular phenogram, like using different color symbols here. So, and this is based on phenology of Tectona grandis. This star mark is basically based on the literature. We found that the leaf flushing as well as this leafless period has changed over the consecutive 3 years when we observed. So the change in concern, we try to understand that in that concern, we found that the change is very much guided by the rainfall pattern. If rainfall is early, the flushing is started accordingly. If it is late, it is again delayed. The flushing is delayed. So definitely it is a very good correlation with the rainfall pattern. So changing rainfall scenarios has affecting the phenological trend of the species also in the region that we have concluded here in the study. Now from here onwards, I am going to some of the hazard events that has been studied by my team over the last few years, and how the remote sensing and GIS application altogether is we are using to understand this scenarios. So again, as I shown you previously, the urban growth pattern here again for the city of Srinagar, it was prepared from 1972 to 2014. We can see how the drastic or almost 80 square kilometer area has increased in the Srinagar city. From purple is initial one, and we can say red, the outskirts is up to the higher limit of the build-up area in 2014. And we can see it is a ward-wise distribution of the build-up area, and based on the data sets, that is not the SAR, basic optical data sets, the certainly a Cloudflare optical data was available. We have tried to understand, overlay this flooded area that is in blue color to the with the build-up area, and try to understand how much and where exactly the build-up areas were inundated. It is the 2014 flood in Srinagar is basically one of the devastating flood, which was almost one of significant flood in last 90 years in that region. So we have tried to understand how this particular flood scenarios. This is the field satellite image of that area. We can see the entire build-up, highly build-up, highly dense build-up area is inundated with the brownish water, that is the flood water itself. And we have used this information, flood inundation and the population density, to understand the hazard and vulnerability, and finally the risk. And we found that the density, the flood hazard is basically in the southern part of the Jhelum River. The southern bank of the southern wards along the Jhelum River were inundated because of low-lying area, where the density is definitely population density is central part, found in the central part and the western part also. But while we combine these two, we found that again the central part is very much affected because of the high density of population, whereby ward number 25 was moderately affected because of the a bit less population, like build-up area was there. So that concern we have identified. And the thing was that when we try to understand the what is the triggering factor for such large flood inundation in the region, we found that the 2014 flood was definitely a very high impact in the region. But when we correlate it with correlate the flood, this condition, the rainfall condition in this region, which is one of the very triggering factor, we found that it was not so high as it lead to the such devastating flood scenario. When we check it with the, we can see this basically the monthly, we can monthly precipitation scenarios are intensities are plotted here, because the 2014 is here where the flood occur in the month of almost September. When we have plotted here, we found that the intensity was not such high as in 2015 and other periods also. Even in 2015, the cumulative rainfall were very much higher than 2014, but it is not reported as a flood period. Then we have tried to investigate the entire flood, entire Kashmir Valley for this concern, and we can found this upper catchment area, and the Srinagar is almost here, and the Jhelum River is going passing from this area to going to the Pakistan from this side. We found that the rainfall was very anomalous in the past few weeks in the upper catchment of the Srinagar Valley, and this area is totally saturated. The high runoff from this side, the upper catchment, when it's coming to the Srinagar city, there was a moderate to high rainfall in the Srinagar city itself, which is leading to the saturation of the soil is there, surface runoff was going on, and additional supplement water from the upper catchment leads to a devastating situation in that area. And water was almost 7 to 8 days, 10 days there in that region. Other than that, we found that when we deepened down, when we go at the large scale assessment, we found that the southern part of the city, basically this part, was having outer side of this part was having some of the black spots, which we have identified during a field visit as a some barren or left out area that act as a water sink zones during the flood season or rainfall season. That area is basically now transformed into build up. So whatever the basically area, those area which is acting as a water sink during the flood period or peak rainfall period is totally not able to take any water in that. They are not able to sink the water in that. They are not able to soak. So that water is also supplementing to the city regions for the with the topographic concern in that area. So it is leading to the high time inundation in this region. So definitely the anomalous rainfall trend, the erraticness of the rainfall pattern, as well as the we can say unplanned or unsustainable build-up growth in the regions lead to such devastation. Another study in Kerala 2018 flood, we have tried to understand the land use change over the years. So we have plotted the land use in the year like in the year 2001, how it was there, and in 2018, how it was there, and how the land use change, as well as the precipitation scenario we try to understand. Then again, the precipitation was definitely high in this region during the flood when it occurred in 21 to 27 August 2018. Parallelly, this is the TRMM based satellite data sets that we have used to understand the precipitation over the different weeks. We found that the week definitely 2 was very much dominating with the high precipitation. This is a cumulative of 4 weeks data sets, and the northern parts were very much affected with the high intensity, high precipitation. And this area we have mapped with the star. This all blue marked area is flood inundated areas, active areas based on SAR, Sentinel C, Sentinel 1A, C-band SAR data sets. And we found that the inundation were observed in these many districts of the Kerala, but the inundation was supplemented by the release of excess water from the upper catchment. Again, the high rainfall was received in the upper catchment regions, and there was a dam, and because of the release of water, considering the overspill of the water from the dam, when it was released, it leaves the situations devastating. So we can see in every cases somewhere the human influence is already there, which has increased the risk or the devastating or impact in the region. So these consecutive 2 slides, I am going to show some of the cases from the tropical cyclones. And in this, we have tried to track the basically precipitation concern in the region. This is the Bay of Bengal and the eastern part of India. We can see that the intensity of high precipitation as the cyclone I was moving to the land area, it is moving along that, and when it strike on basically on 2nd May of 2019 in the Orissa and the coast of this Andhra Pradesh, it lead to move towards the northern side, the West Bengal also. We have tried to see the daily data sets to understand the inundation scenario as with the trajectory of the cyclone in the region. This is a trajectory of cyclone, and we have plotted the buffer along that in the GIS and try to see the what type of land uses that were affected. So we can found that the cities in the periphery was the Kolkata and other cities were there in the outer periphery, which is affected with the some of the moderate to high rainfall in the region. And we have seen the in the proximity we have it, although the very much less coverage area, but the intensity was very high and severely affected regions were there. Along the Kolkata and other regions were falling into 5 to 10 kilometers away, and it was not significantly affected. So when we understand, we come to the other study, that is Amphan. Yeah, we have tried to understand the same scenarios that occurred in 1 to 21st May and 2020. We found that there is a sudden rise in the sudden decline in the AOD concern in this area, Bay of Bengal, and because of that, the temperature, sea surface temperature, was drastically increased during that period, and that sudden increase in the sea surface temperature lead to the cyclogenesis, while the other cyclogenesis factors were very much favorable, and that did lead to the cyclone Amphan. That is one of the very devastating cyclone in this area. Why? So we have plotted this trajectory in the landfall area. We found that again this Kolkata region is under some proximity, not just along the trajectory of the cyclone Amphan, but almost 2 buffers, almost falling onto the 5 to 10 kilometers buffer zone. But it was significantly affected because the intensity and this wind speed was very much high. The rainfall was very much tremendous, and based on the structures, like very much different concrete structures were there, and the houses which was not properly built, and so basically we can say marginalized populations were very much affected in this Kolkata region and suburbs because of the devastating Amphan cyclone. And there one more thing was appeared that it, even though it is coming to this way, there the Sundarban was there, and a large part of we can say Sundarban were getting affected because of this thing temporarily, because of the mudfall and something like that, because of that. But the existence of Sundarban has largely reduced the intensity of this tropical cyclone that we have studied, and because of that, this continuous arrangement of the mangrove in that area that act as a barrier, and uh, almost contributed in the reduction on the intensity of the cyclone when it is falling to, when it is having the landfall. Yeah, this is one of the recent work we have done based on the 2020 COVID risk. We have tried to see the how this pandemic were reported in different parts of the city, in different regions of India. So we have studied this data. Is this all data is based on the 31st August 2020 data sets, whatever it was there up to date, and we have tried to see what is the total confirmed cases in COVID concern. In the Indian scenario, we can see the central part of the India and the northeast and the northern part is very much less affected, and there were very much less cases were there. While the number of deaths is, again, we can see the southern part are very much having the high number of confirmed cases. Accordingly, death is corresponding to the same number of where the cases were very high, the death cases were very high, corresponding to the same thing. And recovering cases is also, we found that it is somewhat higher in this one. And because less cases were there, so it is just a numeric figure that we have tried to plot at the district scale in the entire pan-India region to understand this confirmed cases versus death versus recovery scenarios. Now, this data, this is a GIS representation. We have used this data set to understand the hazard risk situation in the entire region. So, this is, I would like to draw your attention toward this map. Basically, in this we have plotted the entire concern with the hazard, COVID-19 hazard, on the basis of positive number of cases in the entire India during that period. And we found that the southern part, basically the Maharashtra, this Telangana, Andhra Pradesh, and some parts of this Tamil Nadu are very much affected. Also, some of the mega cities, they're also affected with the moderate to high to very severely high hazard or number of cases. While we can see this vulnerability that we have plotted based on the almost 48 factors of the demographic concern, including the gender ratio, then the occupational structure, then other various parameters, and we tried into the fuzzy thing, and we try to understand what is the vulnerability scenario. We found that the Eastern India and Indo-Gangetic plain largely and are very high to high vulnerable. And I know there are many caveats in this concern. Even though if this my speculation is there, my if the cases there came to in the same intensity to the in this region, the coping capacity was very much low, and thus it assumed that the cases there to will lead to a devastating condition in that area. There must something different thing, whereas people are discussing about the immunity and other variables. But in general terms, when we have studied, we found that based on the coping capacity to deal with the basically the COVID scenarios, these areas is very much vulnerable. And the data we have analyzed till 31st August 2020, combining these two, we try to analyze the risk in this region. We found that the risk was definitely very high because of the number of cases in this area, followed by the central part, Indo-Gangetic plain and the eastern region, and also in the western part. While the other areas which have less population as well as the less number of cases reported, like we can see in the northeast as well and the northern part of the India, it is under the less or very low risk. So that type of study we have done, and I'm going to conclude my side. Like these geoinformatics is definitely a very emerging tool, and it can not only support in the identification of problem, also the gravity of the problem can be identified, and based on that we can come to a very effective decisions. And definitely these days geoinformatics not like uh, like a very hard thing or challenging thing. I think every single hand which is using the Android based or Apple based mobile phone, a smartphone, they are again we can understand they are especially literate. They are able to use this Google Map and those things to understand, to take decisions of their spatial term geographical concern. And they are also not only that, they are also understand the smart maps and able to prepare after doing some certain activities, some technical activity they require. After they are able to prepare the smart maps, and again the smart mapping technique is very much popular. And as soon as this man environment interaction is becoming very complex, this geoinformatics tools provide a add-on tool like to understand those the complexities evolving between these two man environment concern. And I have shown you two cases, and this tool are very much popular when we are dealing with the either various problems in terms of the hazard, in terms of the we can say urban studies or the forest studies. So I conclude here, and if you have any questions, please ask.
Thank you, sir, for such a descriptive presentation, and it was very enlightening. So, any of the participants, you have any questions, you can put up. He's there to answer you all. Anyone, any questions?
Good afternoon, sir.
Good afternoon.
Sir, what kind of data are used in seismic activity maps?
Okay, for specific activity, what I have shown you, it is USGS based data sets. And if you go in USGS site, you will find that archival data is available there free of cost. You have to identify the location, as well as you have to identify the period or some that thing. After that, you will get the filtered data. So you will get the data in the some textual form. You have to convert it into the spatial form based on few activities that there in GIS. So you can,
Multispectral data or hyperspectral data?
no. For this concern, this is the point data. USGS provides a point data based on the earthquake event occurred at the world scale. Wherever the earthquake is happening, after few minutes, it was recorded in the this USGS data sets. You will get a data in the point form data, and you will along with the point form you will get regarding the depth of the epicenter, and then its exact location in terms of the lat long, and those things are there. So you can use the data sets for analyzing what I've shown you and other things also.
Yes, thank you so much, sir.
And if you are asking about that devastation concern, it was a different data set.
No, sir, I was asking for earthquake.
Okay.
A very in detail lecture related to each and varied aspects of remote sensing. So I've got few questions from my students that they have answered while we asking some of them. Okay, how to correlate secondary data with census data with the satellite imagery or geospatial data?
Okay. I think whenever any students try to come up with this subject, that is one of the, I think, biggest challenge to understand. Whenever data is there, like I will give you example of census data. Census data is collected at the village scale as well as in urban area ward scale. And when you get the data, I can give you example from village scale itself. So data is at the village scale, like what is the number of population, what is the gender scenarios, what is the occupational structure. We try to fill it with reference to that village itself. And in the spatial data, we have a village map itself. So we try to link with the village name X with that particular census data set of that particular village. So when you plot village-wise data of, suppose we have 100 of villages out there, 1 to 100, and they have population in numbers, then gender scenarios, then age group wise population structure, then occupational structure. The tabular we can link it with the spatial data sets. So in that term we can integrate. This is a norm term, one of the way to integrate non-spatial data sets, that is in the terms of census data, in this spatial data set. One thing is that. Second, that at many times we found that the data in any book, either in form of map that is there, or in the archival map, old structures, and even sometimes the topographical sheets. As that concern, the map, which we can say, like somebody has published a paper long back, 10 years back, and he has he has not shown that long, but the map is there. Like it is a map of Bihar, and that time of 20 years back, the Bihar was united, Bihar Jharkhand was united. You can found the map is there, some information is there in spatial concern, but you are not able to try to take into spatial data. At that point of time, we take the outer margins as a reference from the existing data sets. The outer margins we take and try to georeference the information. Once we do it, then again, when the data I will came in the geospatial environment, I can figure out what are the thematic informations they have given into the GIS layer. This is one of the technique we can use. And in some older data sets, if the lat long is there, then it's become very easy. We can use again georeferencing tool and providing the information of coordinates to that information coming to the GIS layer and extract the information. I think I'm trying to answer in this. It may suffice the purpose.
And there is another question: which data is more appropriate for investigation? Optical data or microwave data, flood forecasting and modeling?
Flood forecasting and modeling. I think for forecasting, you need a different layers, and in that concern, I think the optical data is very much useful. You have to generate the land use land cover map. You have to generate the population density, like in GIS layer, you have to take the census information. Those things concerned. Initial pre-flood investigation, you have to rely on the optical data set and multispectral. But for the time of flood inundation, if you are very lucky, you will get a cloud-free flood data set. Otherwise, whenever the flood is there, there is a huge chunk of cloud which is between the center and the earth. So flood affected landmass. So it is not very easy to penetrate to that. In that concern, Sentinel series satellite, which is pretty available, Sentinel 1A, 1B. So those SAR data set is very much useful in extracting the flood pixels. So you can extract the flood pixel from SAR and you overlay on the land use land cover map or any other map generated from the multispectral. Combining these two, I think you will get this detail. And as far as forecasting is concerned, you have required the various other layers like digital elevation model for the topographical up and downs, and also the previous flood history. What type of flood, what are the locations which is very much affected with the flood over the last 10 years, 5 years, something like that. And you can understand the flood frequency, how it is affecting and related with the topographical high and low and land uses, so on things. So I think multiple for multiple objectives, multiple set of data sets are required.
Another question I'll be taking up: what will be the future scenario of COVID-19 in India on the basis of your existing model?
Oh my God, it is not a forecasting model. It is based on whatever the data was there up to August 2020. We have tried to analyze that particular scheme. So my studies, that particular studies is related with the hazard, risk, and vulnerability concern, that is HRVA. So thing is that as there are many things in COVID, like I have shown discussed you about the caveat, like which is not considered, like social behavior, which is special term is not available, and then the migration activities, again the data is not publicly available, who is moving from which area to that. Many things are available. I think NDMA is working and they have some set of data sets like that, but it is not open. So concern and the individual immunity, it is again variety of concern there. So my study has some limitations, but whatever the variables we have taken into account, we found that the zones which is vulnerable, I have shown you, it is again vulnerable for various scenarios. Either it is a COVID-19 flood or hazard or heat wave, something like if anything happening in that area, zones in the Indo-Gangetic plain, and we can say western part and the eastern part of Odisha and so are very much prone as compared to other parts of India because of their coping capacity is very much challenging. It is not up to the mark in the south. And I feel is coincidence, even though whatever the cases were come up in the southern India, they are very much able to deal with that because population, the health, infrastructure are as compared to these many regions are very much in good condition in that area. So that is one. And beyond that, we have did one study based on the absolute humidity. That is basically the temperature range of COVID-19 that was initially reported that it can survive into certain degree of temperature from I think 16 to 22 degrees centigrade. Based on that, we have generated the forecasting for the few months in the 2000 itself. And after the COVID in the month of May, we have projected it, and we found that the even though the cases were in different regime because now we have coming to that level that it has nothing to do with the temperature as basically the surface temperature because it can host a human body in any situation. So even though the cases which is reported at the worldwide are matching up to 80%. So that type of thing.
Dr. Amit, your voice is not audible. Dr. Amit? Can you hear me, Dr. Amit? Priyanka, can you hear me?
Yes, sir.
Yes, sir, your voice is audible, sir.
Okay,
I think sir is facing some issues.
yeah, he has
He's
joined.
there, sir.
He has
Sir
joined.
has rejoined. Yeah.
Yeah. So I think there are various issues to deal with this problem, and we can use this map and understanding to create the health infrastructure to deal with this problem. That is, I think, my answer for the COVID-19 concern.
There is many more questions, but I'll be taking last two questions are there. Which data is better for LST mapping? Optical data or microwave data, and how to process it?
I think these two data sets are not good for that. And in between these two data sets, the thermal channel is there, like Landsat is providing free archival data sets, and that Landsat 5 to this, we have a thermal channel, 1 to 2 thermal channels are there. That is being used for this LST mapping. That is good for that. And again, when you try to relate with the other parameters, other variables, you can either use both, like you can use SAR data set to understand the forest structure. You can use the urban heterogeneity, homogeneity that concern with the SAR and try to see how they are linked with the land surface temperature variables. I think for land surface temperature estimation, thermal data is the final one, and you can relate the other variables based on the other resources.
And the last question will be, which model will be used for urban forecasting or urban models?
Okay, these days too many models are popular, including CA, cellular automata, then Markov chain. They are popular. Few studies are there in which the fusion of these two were used. So all together, there are means whenever you model, there are you have to take certain variables, and the based on the uncertainty of these variables, the forecasting has been done, and it is we can't say it is 100%, but it is like more than 70%. It may have the project the scenarios. Thing is that these days more improved models are available, so casting models are available, and that those models is also being used. But if you want to start with the modeling study, I think CA and Markov channel is very good to go.
Still, if any question I have left out, so anybody is free to ask directly. I have taken measure of the question because as we have already exceeded the time, and in the second half again we have got a practical session. So if anybody is still with some questions.
Sir, I have one more question, sir.
Yeah, please.
Sir, is there any model or way to predict air pollution?
Yes. Means whatever the model I have told you, projection models, there are many models are also there. So for that sake, you require recently I'm collaborating with of the US institution, and they have a like pollen data sets of different seasons, and they would try to integrate how these pollens over the different periods, including the wind direction, wind speed, and those influence is there, and how they are going to affect the cities, neighboring cities in that area. And that concern, like WRF modeling is very much popular, but again, it requires a huge set of data sets, very detailed. And again, the dispersal from at vertical dispersal and horizontal dispersal, this all can be considered. And for that sake, you require a very huge set of this particular hardware also, computing system, that can only be used for this type of assessment.
Okay, sir. Thank you so much, sir.
And with this, I feel that majority of the question we have answered. And on behalf of Center for Climate Change and Water Research, Suresh Gan University, Jaipur, Rajasthan, I would like to, from my heart, like to thank Dr. Amit Kumar that from his busy schedule, we requested he had prior appointments, but I requested him because he is one of the best working in the field of geospatial technology, and you can see by the work he has shown, ranging from flood, forest, nothing was left, whether you talk about optical or microwave or hyperspect. So he's an overall all-rounder working in the areas of any of the data sets that you talk about in remote sensing and GIS. And he's a great asset to our nation or and the various university, and any of the students who wants to take further guidance, wants to collaborate, can contact him directly. He is a very good person and then a nice human being. So with this, I thank you again that you have blessed us, and our student will be hoping your further blessings and cooperation in near future. And with this, we come to our end of day 15, session 1. Again, we'll meet at 2:05 for our practical session. Till that time, you can
Thank
take
you.
your lunch. Thank you.
Thank you. Thank you.
Thank you. 2:05 में फिर मिलेंगे लंच के बाद, ठीक है?
Okay, sir.
चलो।
Okay, sir.